Good evening to all.
Good evening, sir.
Good evening. Very good evening to all respected faculty members, researchers, and distinguished participants to joining us with online today's Atal FDP AICD sponsored uh, on building sustainable infrastructure for urban and social resilience, challenges and future pathways. First of all, Happy New Year to all participants. It gives me immense pleasure to warmly welcome to you all the inauguration of the 6 days online Atal FDP program titled Building Sustainable Infrastructure for Urban and Social Resilience Challenges and Future Pathways. We are honored to have an esteemed gathering of faculty members and researchers from various institutions whose presence truly enriches this program. Also, this FDP is thoughtfully designed to enhance academic excellence, promote research-oriented discussions, and foster meaningful collaborations among educators and researchers. Also, we sincerely hope that session will be insightful, engaging, and beneficial, offering to valuable knowledge, practical insights, and opportunities for professional and academic growth. So this is very important point of view. We encourage your active participation, interaction with resource persons, and collaboration with fellow participants. Also, throughout the program, when you are attending in personal or virtually, then it is very important point of view that the program objective is designed for particularly related to new construction technology in civil engineering and their approaches regarding infrastructure management. So it focuses on imparting the knowledge of recent techniques, policies, best practices in civil engineering, also sustainable infrastructure solutions, also to provide hands-on demonstration or modern tools, sensing technologies necessary for health monitoring and infrastructure, also a skill of educators in various aspects of infrastructure, including transportation, sustainable construction, and emerging technologies. Also, this program's has main motive is for to train the faculty members, researchers, civil engineers with capabilities through the emerging techniques for solving issues related to the sustainable engineering infrastructure. So it is very important on point of view this Atal FDP is designed. So thank you for joining us, and once again a warm welcome to all participants of the Atal FDP. We wish you rewarding and enriching the learning experience. So uh, from my side is over. Now Mukune sir, our Dr. Shailendra Kumar Mukune sir, principal. Uh, or to all the participants giving some thoughtful suggestions. Bukne sir.
Hello,
Yes sir.
good evening all. Uh, my colleague, Dr. Gunwant Pate, coordinator of this FDP, Dr. Shrikant Bobde, co-coordinator of Shuttle FDP. I think today's resource person also joined Dr. Tarendra sir. On behalf
Yes
of
sir.
College of Engineering, I welcome you all and dear participants. So, this being the FDP on building sustainable infrastructure for urban and social resilience challenges and future pathways. I think building sustainable infrastructure is the need of hour, and this particular FDP will give you enough insight such that whatever students you are going to groom in coming days, they will be more, more inclined towards sustainable infrastructure. Now, when you say sustainable means in what sense sustainable? Nowadays, major issue of sustainable is the environment and our ecosystem, preserving our ecosystem, preserving our environment. So building, I think, environment friendly, eco-friendly infrastructure is need of the hour. And being the technocrats in civil engineering field, all should think in that direction and allow our students to think in that direction. So I think this 6 days Atal FDP give enough inputs such that you will groom the coming students in that direction, coming technocrats in that direction. So without taking much of your time, I once again wish you all the best for this 6 days enriching Atal FDP on building a sustainable infrastructure for urban and social resilience. What are the challenges and what are the future pathways? Hello. So I wish you all the success in your future endeavor. Thank you. Hello. That is it. Hello. 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 I have finished mine.
Kate sir, you have to unmute yourself before you speak.
Yes sir. Yes sir. Yes sir. Uh, Thank you Mukne sir. Now our Bobde sir is introducing our today's guest, first session.
Good evening to all the participants. Uh, Day one session also. Today's expert, Dr. Lakankar sir. These are the research scientists, the City College of New York and New York, USA. Area of expertise for this, the remote sensing and GIS, urban extremes and wilderness field campaigning, there are so weather station networking, statics, data sciences, and Dr. Lakankar has lead and coordinate various research projects contributing to NOAA and NASA satellite remote sensing missions in water prediction and ecosystem services research. Dr. Lakankar sir has demonstrated exceptional leadership skills by designing and leading several major fields campaign sites. These projects have provided valuable data research, improve the accuracy of weather and water predictions, and increase public awareness of environmental issues. These projects have resulted in successful outcomes and publication in top tier journals. Dr. Lakankar sir has also served as a mentor for several research projects and contributed significantly to NOAA satellite remote sensing missions. He has also contributed significantly to research in water prediction and ecosystem services.
I think we lost Bobre sir. बोबडे साहेब तुमचं इंटरनेट गेलं वाटतं.
Yes, sir. Yes, sir. Yes, sir. Yes, sir.
So do you want me to start?
Just a minute. Just a minute.
No.
Dr. Laftinger has shown were recognized with the Star Award in 2022. Dr. Laftinger was in his teaching career to the City College of New York, where he has imparted knowledge across several courses, including GIS in water resources, geography in information system, introduction to satellite remote sensing and imaging, environmental system science, and environmental water resources. His teaching philosophy centers around inquiry-based learning, fostering scientific inquiry, honing data analysis skills, and cultivating effective communication abilities in both written and oral forms. This approach significantly boosts students' capacities in problem solving and research. Dr. Lakankar has dedicated for his summers to teaching high schools with the undergraduate students, extending his education impact beyond the regular academic years. Dr. Lakankar, sir, over to you.
Thank you, sir. Allow me to share a screen.
Yes, please share.
Okay, can everybody see my screen? Somebody unmute and tell me.
Yes, sir.
Okay. आवाज येतोय बरोबर सगळ्यांना?
Yes, sir.
Yes, sir. मला स्क्रीन
Okay. तर काकीसर सगळ्यांना म्यूट करून टाका तुम्ही. Can you
Yes, sir.
mute everybody? Some hosts should mute everybody. So no background noise. Okay. चालेल. काटे सर तुमच्या ऑफिसमध्ये सगळे लोक एका सोबत बसले आहेत आणि ऑन आहेत. That's why the echo is coming. So make sure that everybody turn off their microphone. Only one person keep on.
Okay, okay.
That's what the problem. I mean, everybody is there. Okay. All right. Sir, namaskar. So, okay, let me start actually. So again, thank you for inviting me for this wonderful session of Atal presentation and workshops. So as Karteshwar mentioned about my and Bobeswar mentioned about my area of expertise, I work in the field of remote sensing. I am my bachelor degree in civil engineering, my master environmental from VNIT and PhD from City of New York. I was in IIT Bombay for a few years for PhD, but I left IIT Bombay and got good opportunity in USA and came here. And after last 22 years, I am in America in New York City as a scientist and a professor. Before I go further, this is my background where I belongs to. This is a small village in district Bhandara, Gondia, and which has my house. Today, in fact, I was in Mundigoda, same village, which you see in the picture on the left side. And this is a station where I grew up selling teas in the train stations. And I'm the five brothers, and I just put timetable there. So my journey start here from this small village to the New York City. All right. So what I'm doing again, let me repeat. These are some of the pictures of my field campaign I do here. The research scientist. I'm a PI of this big project. If you look at this whole picture on here, me and these are all white things you're seeing here are the sensors, which call satellite sensors on the ground, and the small sensor used to build a model which applying to the satellites in the space, right? So this satellite means the like a car with the number of people. So each satellite has a multiple sensors and which take continuous images from the space to the Earth. And there are a bunch of sensors other than micro sensors. There are gamma ray sensors, infrared sensors, visible sensors, and all instrument on the ground also to measure temperature of Earth's surface when the snow on the top. And there are so many applications of those full experiment to from avalanche to snow data, snow depth, snow water equivalent, and so on. So with the funding from the Department of Defense, NOAA, NASA, I built this big field campaign where several of my PhD students graduated from this research. This another research I do with the NASA, and then recently ISRO is part of it with the NICER mission. We launched together with the NASA and ISRO, and which is a part of that mission is to measure the soil moisture in the ground, so much moist in the soil, which can help to predict the flash flood, predict agriculture growth, and other so many applications. So this is a big project where I'm with NASA and NOAA teams here, along with the Department of Defense teams, and those are the sensors, the L band radiometer we call, and which is similar frequency radiometer is in the space in the what we launched together with NASA and ISRO. And those are field campaign done with the multiple places from forest to agricultural land and so on. Not only doing the research, but same time we involve several PhDs, undergraduate, master, and high school students, make them learn what is this technology, what is the NASA is doing. Okay. So those are just picture, and those are the other area where I'm put lot of sensors in the Puerto Rico zone of the US island in the Caribbean, next to the all the cricket field. If you must have Barbados, Kingston, the West Indies teams, those are the islands where we put on the sensors. In addition to what I'm doing with the research, after inspiring from the Mr. American from 3 years, I involved with the high schools. In addition to my university job, I installed weather station in the several high school in New York City, and what map you see on the right side is the New York City map with the multiple boroughs, right? So I involved with a lot of high school students, teacher, and so that they can learn science while doing the studying the high school. So to motivate them basically, and all those data collected by our server, and same time from the space we have. This is what you saw on the radar system here on the left side bottom is all about the satellite receiving station where we data from satellite we receive at my university, and we compare what we gathered on the ground using the weather station you saw in the multiple locations in the picture and different high schools locations. And then in addition to that, a lot of activity in whether India or America or different places across the world. So some of the pictures, and then also we developed big collaboration with the New York City mayor, which write the proclamations that India-US partnerships. And then this is the uh, Sri Governor of Maharashtra, previous Governor of Maharashtra, Koshari ji. Okay. And then this picture of different universities in Maharashtra, from Andhra University to Vignan to the Sri Sri Ravi Shankar University. Okay. Coming back to the little topic, what we're going to talk today, that what is sustainability? I mean, sustainability means how to elongate our Earth's future or our health of future, right? Through the various activity, right? And then we have to find out what does that mean? Means what we changing actually, what we improving. So there are a lot of variables, call it climate, essential climate variables, right? And which are the parameters we use to monitor climate change. So if you're defining climate change, which is the change in the statistical properties of climate system when considered over a long period of time, means months, years, and so on. So if you look at this last 5 6 years, the number of hurricanes uh, which is coming from Orissa or Bengal, Bay of Bengal or Tamil Nadu is increased. Not only increased in India and Asia, but also increased a lot in the Americas as well. So that's a one thing, and this can be not only hurricanes or one thing, but there are so many things. Your agricultural land is deforestation, another thing. So there are so many things, candidate, which we need to compare from last 50 to 100 years and see that what is happening in those parameters, right? And where do you are those, right? So the GCOS system, which providing a list of those all variables from the temperature, which tell you global warming, to rainfall, which tells about how many hurricanes happening, or soil moisture on the ground, or deforestation, and so on. There's so many variables. But there are some variables, I will show you a list there, which we consider is a climate variable. And if we try to improve or reduce the impact of this whole impact of the global development or so much of carbon dioxide limiting, and so on. So how to protect or reduce that variation in those variables. So that's we'll talk about later in few minutes. So those monitoring of data, whether rainfall, temperature, as of that called climate data records. So which is normally data records in more than 20, 30 years and so on, right? And out of that, there's some variables which called essential climate variables, right? And that is support the work of United Nations framework that we call IPCC, right? Which define those variables, right? Okay. And we tend to see that all those essential climate variables should be technically and economically feasible to measure on the ground, or measure on the ground, or measure by satellites. So we'll discuss about those variables which can measure satellite. Not all the variables can measure using the satellite, but there are some variables can measure as well. So there are, we list 55 essential climate variables that can be used to measure impact, which is impact on climate change as a part of climate change, right? So here is a picture of all the 55 variables, right? And those picture shows in the cryosphere, whether snow, ice sheets, glaciers, Antarctic, Arctic, which is melting because of that ground sea water level increasing, and if that increasing, half of the Bangladesh or half of the Dhaka will be gone, or part of the Maharashtra, Mumbai, will be under the water because we are building the walls across the ocean to avoid the water coming in the city. But if the water will increase after a few meters or few feet, of course, water will come inside the city, and then some of the land will be go under the water. And not only Mumbai or Dhaka, there are several cities, most of the big cities across the world, including New York, Los Angeles, other cities. They are part of the coastal, close to the coastal. So those cities are in danger of the being in the water. We are lucky that we are in Maharashtra. I'm in Nagpur. You guys are in Nashik, Malegaon. So okay, but the big trouble is those cities where stay in the coastal, where Chennai, Kolkata, Mumbai, and so on. Okay, and those are the talking about the glaciers melting, but there are surface parameters, which is surface temperature, right? Sea ice on the ground, and so on. So all those variables are changing due to the climate change and global warming and so on. We need to monitor longer record and now see that the variation is there. Okay. So from the cryosphere land, surface observations, upper air means upper air movement, right? Uh, if temperature changes happen, so more evaporation will take place. More evaporation takes place, more cloud formations, more rainfall, right? More faster the cloud formations, faster the movement of hurricanes or cloud movement, right? And that faster cloud
Yes.
movement, faster rain, faster flooding, more flooding. So the all interlinked variables are there, which is working together. So एक अपने घर में एक घुसा सब लोग झगड़ा करे तो वही हाल है यहाँ पे क्लाइमेट वेरिएबल्स का. एक वेरिएबल चेंज हो गया, so all other variable impacted and they act weird. Okay, so this is the list of variables I mentioned. Now let's come back to the satellite remote sensing. How satellite remote sensing can help to measure those parameters, those climate variables, right? And how satellites works or work on based on the waves, whether visible waves, which is our eyes, infrared, thermal infrared, microwave, gamma, and so on and so on. So those all wavelengths or frequencies we use to measure the several parameters. So here's the picture. What you see is this wavelengths from the radio wavelength on left side to all the way gamma rays, from the microwave, infrared, visible, ultraviolet, X-ray, and gamma ray. Of course, X-ray and gamma rays we use often on health issues, but some of the gamma rays also we use to monitor soil moisture on the ground or snow on the ground. Okay. So let's try to understand what are those waves are. Of course, when I speak or when you speak, we speak in the range of 150 hertz. But those when you talk on the phone, finally let's talk on the phone. You everybody using phone nowadays, 4G or 5G, right? So what you do basically you speak in the frequency of 150 hertz. Your phone convert that frequency wording what you speak in microwave frequency from 2G 3G means 1.6 to 3.3 gigahertz in the frequency, and sending that signals to nearby cell tower. बोलते हैं ना signals tower यहाँ पे नहीं है. So your cell phone send the signals in cell tower. Cell tower send to satellite and space, and then that's another cell tower, and the cell tower send that another somebody's phone, and that phone convert that microwave frequency wavelengths, which is around 1.6 to 3.3, to the audio waves were like 150 hertz wavelength. Okay, so how this system of microwave frequency along with the radio frequency work together. But same time also your radios, FM, AM, right? To the frequency. If you go little bigger wavelength, which is called a microwave wavelength, right? I'm not everybody has them. Some people of you must have microwave at home, which warm the food, right? But we use same frequency, which is warming the food, or same frequency we're using to Bluetooth to connect from your remote to the TV, right? We have higher frequency we use to monitor the rainfall, how much water droplet in the sky when it's falling, or how much water in the ground, or how much snow in the ground. So we'll talk those frequencies later as we one by one slowly discover that in part of the few slides. And then come infrared. We present outside, right? When you sit outside in the sun, your body warms up, but you don't see it where it coming from, right? But still warming up. What is that frequency warming up your body? Daytime when you're sitting outside. So that's called infrared frequencies, like thermal infrared from sun. There's somebody making noise. Can you mute yourself, please? Or somebody mute that person who just joined. So there are frequencies infrared which warms your body. So that's thermal. Kate sir, can you mute anybody coming new? Okay,
Yes,
so
sir.
those are the
Muted.
infrared
Muted.
frequency we talk about with thermal infrared, and then visible lights, which is only frequency is a human we can sense around us because visible light, visible wavelength, right? And then ultraviolet and other X-rays and gamma rays, right? So of course, everybody of you familiar with the X-rays. You go to hospital, you use X-rays, or you go to the hospitals to the MRI. So here's the picture on left side about talking about AM, FM channels, frequencies, and the middle figure shows a 1G, 2G, and you heard that 1G, 2G, 3G, and GG, everything in news, right? So those are those channels, right? And then right side is about the other. Okay, so then I talk about infrared frequency. Within infrared frequency, we have so many applications for the light. from the river blockage, right? In the northern part of the equator, right, hemisphere, lot of river become frozen in the winter time because of the cold weather, whether Russia or UK or Norway and Sweden or American Canada, right? So when the water become frozen and then start melting, suddenly river block and flooding started. So we that's the one area says infrared temperature, infrared sensors used, right? Missile guidance. You must have heard a lot of fight like in India, one Operation Sindhu, right? How you track how the missile coming and you exactly hitting the same missile. What is technology is there? So we use thermal channels. So each missile has thermal channels, a sensor in it, and which measure the incoming missile, which is normal warmer than nearby air, right? And it would hit a target. So that is thermal channel. That's the thermal frequency wavelength we use, right? And then remote controls. You always use remote control to turn on TV and turn on channels. That also is the near infrared frequency we use. Forest fire, a lot of forest fire happening nowadays, right? How to satellite measure in thermal channels, right? And so many things. But typhoons are moving around. This all you saw the last couple of weeks. Typhoon hit in Orissa, right? How we measure that? The movement around all the big clouds is infrared. Mineral explorations, earthquake monitoring, right? Rock failure detections, right? If you sit there, you can also detect the cracks in the building, cracks in the road, cracks in the column or beams, right? Those are thermal channels used, and so on. And healthcare, a lot of impact. But yes, so those are the infrared frequencies we use for several applications. And within that frequency, big range, we use smaller width, bigger width, and so on. So there are a lot of applications. After that, you all go through security, you go to the mammogram, you go to the CT scan, you heard the word MRI, all those frequencies used in the field of X-rays, the longer wavelength. But X-ray is a common word we use from hundreds, that's why we call X-ray. But X-ray is a smaller frequency within the range of the whole X-ray range, right? But yes, we use those four frequencies from airport security to CT scan to your teeth to your bones, and then lastly is gamma ray, the another frequency, which we use, you must have used if those are people of cancer, to clean the cancer cells from close to your stomach or your blood or brain tumor and so on. So there's another application of those frequencies of gamma rays. But same time, those frequencies can be used detect the inside the vehicle also. Okay. So there are so many spectrum. This is a big spectrum. And this whole spectrum, so far, we as a human able to research and find out. Let's start on another figure. And I'm telling you, all the sensors are also nowadays not costly. If some of faculty are part of the electrical engineering or electronics, they can buy those sensors nowadays with the cheaper 100 rupees or 200 rupees, 300 rupees, and student can make a small projects based on those frequency. I know you all faculties think in that direction. If you're building a project for students to measuring a smaller things from earthquake to for temperature rising. Okay. So let's within this let's go back to the smaller frequency. We talk about the visible length here and the central part of the map. So this frequency visible length is divided into seven different colors, seven bands. We call color or band, the same word we use. And those from the 380 or zero point 0.4 micrometer to 7 micrometer. N is a nanometer here. And within that range of zero point 0.4 to zero point 0.7 micrometer, we have multiple band from violet, blue, green, yellow, and sometimes when rainy seasons, you must see the Indradhanush, right? Indradhanush, the rainbow, right? So rainbow is a mix of all the color, what I see on the left side, right? So when reflections throughout the droplets, and when you see the some object at your home, you be seeing this uh, background is green leaves or a background wall is the behind with the pink or purple, right? What it means that it absorbs rest of the light, only reflect that light, like like in the leaves reflect only green light. That's why we see green color of leaves. If my background is the purple, so it's a purple color, and so on. So the based on the reflection of that dye or that object, table, everything, are based on actually other energies. Okay, let's take another frequency we call thermal infrared, right? So if you see this picture here, if I take a picture in thermal band, right, a visual near infrared band, so the with normal eyes, you see the picture on the left. With the thermal channels, you see the picture on the right. Similarly, if this man, right, holding cup means hot coffee and water in the glass, the reflection will different in thermal channels. different. Like if you go hospital nowadays, right? During COVID, we developed the temperature gun, right? Temperature gun. So temperature gun only release one ray of the light. If you're releasing multiple rays, you can take a picture out of it, right? Difference here, the temperature in doctor hospital take only send one signal, one ray, and measure what is reflection back. In this case, you send multiple rays and create an image of multiple rays you send and reflect, measure, reflect back. Same exact concept. We convert in the pixel format, numbers. Right? Each image is what we call it is a pixels, right? We have numbers, and that number we replay, develop a linear equations. Which in those higher value, if the white means value is 255, if you see the mouse here, the white, the cup, hot water is a 255 and dark is 0, means the value of 0 to 50 range. So in those values, you can develop a linear equations, and that helps to measure the temperature globally, each of the location with the pixel of 1 kilometer pixel. And this is land surface temperature. And we use those data from last 30, 40 years to see that how much temperature Earth was warming. Right? So one example, and same frequency can be used to the nighttime measuring the moving objects. Because Earth's surface is a cooler, your human body always warmer. Every human body, your human right now, if you're a healthy person, is 90.5 degrees Fahrenheit. Right? So, but Earth's surface is much cooler. Earth's surface is around 70s, right? So the 20-degree difference by your body temperature and temperature wall or sitting where you're on a train table or something. Touch your table, you see that's much cooler. Okay, so example is that. So you measuring temperature of certain satellites and giving predictions. Another next to the visible band of thermal is called night visions limit, which is 700 to the 1000 nanometer, just above next to visible band, and which help to see the nighttime objects. Like the owls, right? The goober, right? All they can see nighttime because they have sensed that frequency. Dogs can see little bit some of the night vision, but human cannot see more than 700. They always see 400 to 700 nanometers. Okay. Then next to the night vision spectral camera in infrared thermal channels, which is from 9,000 to 14,000 nanometers, and which measure temperature of the object. Okay. So this all the frequency channels when you put in satellite, right? As a one in a one satellite. Satellite I mentioned the satellite is a sensor. Okay. There's an animation which is not playing right now. But yes, so when putting the sensors in the one satellite, like one vehicle or one car, multiple sensors with cameras, you can monitor continuously data globally. Right? So instead of multiple different style of type of instrument, satellite can give same data across the globe. And with picture inside right side here is there are multiple sensors, the multiple frequency collect data continuously, and which can help to merge multiple data together, and it will be cost effective also. So here is a bunch of list of satellites from, and those satellites either launched by US, Japan, China, Europe, and India has also become a leader nowadays. Last 10 years or 15 years, India sent lots of satellite in space and become one of the big in a market of satellite remote sensing. Not only data is used by the Indian government, but also the foreign government. So here is a lot of opportunity for Indian researchers. If whether civil engineer or aeronautical engineer or what is engineer, you can use those data for all of your projects. Okay. And here's a picture of number of satellites in the space. Right now, there are around 4 to 5,000 satellites in the space, but out of this, around a lot of satellites become died because of the battery and solar panels died. Okay, Curtis, can you mute this person who joined recently? So those satellites we just show in the pictures, they are satellite different types. In our case, we call remote sensing satellites, which is measure the different frequency. But there are satellites which are communicating satellites. I mentioned that your cell phone is communicating satellite. Your TV towers, sorry, your dish at your home, which collect the data, which used to see channels on TV, our communication satellites. There are navigation satellites which use GPS on phone your works. Your phone, when you use the map, Google Map on the phone, continuously sending signals to satellite and giving exact location of yours, right? And then there are geosynchronous satellites with the height of the Earth, which location, right? There are geosatellites which is stay continuously the same. Like even Earth is moving. Even think about it, right now, you in the space, each of us, everybody of us in the space moving at around 300 kilometer per minute speed. 300 kilometer per minute speed. We are moving in the space. 300 kilometers, but we don't feel it because we habituate of it, right? Earth is moving, Earth is moving, right? So Earth is moving in 20% complete one cycle. So think about this big Earth moving, you are also moving in the space, but we don't feel it. Anyway, but satellite that you said, even the space around 10,000 feet, kilometer away from Earth's surface, is also moving and taking pictures continuously, right? Then drone satellites, polar orbit satellites, which is from uh, north pole, south pole, the country is moving, and so on, right? And these pictures give a which height the satellites are, right? Your airplane, if you see the airplane in the sky, it is normally move at a stay at the height of 10 kilometer away from Earth's surface. So satellites can step to 36,000 kilometers and taking pictures from that height of Earth's surface. Think of how what speed they must be moving, right? And then polar orbit satellites just around 800, 900 kilometers away from Earth's surface and continuously moving. So this all satellites, all those airplanes or some and other drones, they continuously measure the Earth's surface, different parameters. So let's talk little differently more about this those visible bands versus infrared bands and how we build the pictures, right? Here's the one examples, right? We have red, green, and blue channels. Our eyes, when you see the multi-colorful image of our surroundings, they combine all the bands we call RGB or multiple bands I've shown you before, right? Violet and everything together to give one picture. A satellite can take a picture of different small band, RGB band, right? Let's take example of three bands from zero point 0.4 to zero point 0.7 nanometer. Here, the size of the bands here, as you can see, my mouse is moving. So when you take a picture of three different bands, I mean, combine with their RGB red, blue, green, you can make a final color. And that when you if right side here, blue color merged with the green and red is become your true pictures. When we are kid, we used to mix the two colors, yellow versus blue become a green and so on. We played with the colors. When Chitrakala class was there in the 5th grade to 10th grade somewhere. So what we do is we just to restrict those color combination mixing together. Exactly same thing. Satellite, when each band color is mixed together, clear real images, right? And here's a picture of different band satellites can carry. Those digital Landsat satellite carry multiple band, one, band two, band three, and each band have different frequency. But here the good thing here that each band have unique capability. The blue band can help you to measure the algae or water quality and the lakes or ocean. Your green band help you to measure health of the vegetations. Red band also help you measure health of vegetation and so on. So each of the band has very application for different purpose. Here is the list here. So for blue band, I mentioned water quality, coastal and aerosol studies. Band to blue band is for bathymetry and so on and so on. So each band, I mean, separately taken pictures can be applied for multiple things, multiple applications from forest fire to the health of the crop, soil erosion, and so on. So satellite is a vast subject. There are degrees in satellite remote sensing, but I give an idea that how can be used. Let's give one example. So we all worry about the clothes or crops, right? When droughts happen, everybody claim every district claim that hey, Myra district में drought हो गया, right in Maharashtra, and then ask God funding. But government is smart. They map the health of every district, right? And what we do, we use two different bands, red band and near infrared bands. And with a reflection there, we call measure vegetation index, right? So because dead leaves are have different reflection properties than healthy bands. Healthy band infrared has more reflections, right? So with the real reflection properties of the leaves of your crop, whether it's a wheat or corn or rice, different reflections. And those reflections, we build an index called vegetation index, and continuously monitor that index every weeks, and it can give an idea about which area has fertile land, which has fertile crops, and which has a droughts, and that continuously monitoring. Not only matter that from satellite, but also we can use drone. We can fly the drone and we can measure health of the crop. Here is the when green color vegetation are healthy, and the stress vegetation shown in the different colors when you merge two colors. And so when we use this technology, you can tell us that how the health of vegetation across the, and these are example of one map. Wheat production in India, we can monitor those, which areas high wheat production, high rice production, high maize production, high corn production, and so on. Okay. And then here is the idea how we monitor that, how much crop production will happen in each yield, right? Yield goes there, right? How much production will happen? So because of health of the crop, because NDVI value of the crop, which we just shown NDVI value, right? It's like बच्चे का टेम्परेचर हम मेजर करते हैं एवरी हर साल वेट गिनते हैं बच्चे का, छोटे बच्चे का, कि नॉर्मल ग्रोथ हो रही है कि नहीं हो रही है. It's the same concept we use for crop growth for each of the districts wise. And when you see this red line here, here that means that crop that district has a less healthy, so we expect less production. Right? And that way helps. So once we know that how much expected yield is from that districts, we can properly planning things takes place. Okay. So this is one of the example of the food production industry we monitor. But yes, there are so many other applications. I mentioned that forest fire is another area. And let me tell you another things. These are list of satellites. You just take a screenshot, take a picture of it. So satellite data is freely available. Satellite data is not costly. It's freely available. From last 30, 40 years of data sets. So if you choose somebody want to choose to work on your own district, whether Baramati or which your district, Nashik and so on, can download data for each of the district from last 30, 40 years and see what is the India value changes from last 30 years and so on, right? Or which is in value changes and so on. Okay, so here's a list of it. And I will ask Katisha to share these slides to all of you. So you can go back and search those satellite names here mentioned here and download the data. And I mentioned that once you know the crop productions, you can manage better. Because what we still working on, our India is still working on a system that how to preserve all the crop productions, right? So when you know how much production happen, you can manage better. If you see higher production of wheat or corn or something, you can build more go downs, right? And so on. So this is one example of food productions. And then also satellite monitoring. Okay, another thing satellite measure is the rainfall, precipitations. Nowadays, every year there is a flooding. Last year, Nagpur has flooded heavily because rain within 1 hour we have 3 to 4 inches of rain. Could be tomorrow in Nasik or Malega or some other cities, right? We need to know beforehand how to prepare beforehand. Hey, tomorrow heavy hurricane is hitting Orissa or Chennai or other Mumbai, right? So we can measure this rainfall precipitations. Not working anyway, right? So that's another area of measuring rainfall. Right? And there's a global precision measurement. There's a missions launched by NASA, JAXA, and maybe in the future ISRO is starting involved with those rainfall measurement project where we can 24 hours monitor how much rainfall is expecting in each of the district in the India. Another applications of the satellite is land use land cover monitoring. So, the last 10 years, several forests are being deforested because of building roads, building houses, building buildings. Every year, building farmhouses and cutting a lot of trees. So this is another example. As we can tell you that which area is deforesting year by year. Right? So that's changing land covers. And of course, population increasing, we need more houses. So definitely, because either you have to think about people or think about forest. And of course, we are humans. We are super most powerful living organism on Earth. So we are first preference. So we can do anything. But anyway, objective is to not to tell that. Objective is to that we can monitor changes and make a if decision in future that hey we can put more trees or, put more trees in our area. Here's an example of RA colony, how this thing changes. So this is a picture I took from Google Earth, allow you take picture of multiple years background, right? So how this eye color in lake is are to change. And you can see the changes. These lakes become a small every day by day reduce. And this is not example of one lake I've shown you. Are you from small village or town? You will know that lakes in your town or village, maybe when you're young, is much bigger. Nowadays, because of all the throwing garbage or whatever, it's because reducing day by day. Or any bigger lake or dams also reducing. So think how much we impacting us on our surface. Another example, forest fire. Nowadays, everybody is easy to when we harvest your crops. What you do remaining, we burn the crops remaining, whatever left over. That's again, and not only that, burning crops, but also forest fire because of when it's dry weather is there, forest fire. So this is a map of active forest fire incidents. So we monitor some satellites. Those are forest fire examples. And the example of irrigation land and so on. So satellites can help you to tell you that in winter time how much area of land under the water may irrigate because there's no rain in the December or January, right? So that time satellite can help you to which area, how much area is irrigated by the water in the canals. Soil erosion is another example of satellite mapping. Another example, I think few years before next to the Nasik, I heard some places we have the landslide happens. Village come under the soil right next to one other village. I don't remember what exactly village district was that, but that's another. When soil moisture has become too wet or rain completely coming several days or weeks, when soil become too wet, is always slide down, right? So we need to monitor that soil moisture is another parameter satellite can give you. Flash flood, right? If soil already wet and same rainfall happens, all the water can go nearby stream or flood, right? Or river, and so on. Our military has been very particular about soil moisture project. US military is very active, accurate in terms of seconds and minutes when attacking enemies, right? So you need exact precise movement of your tanks because tank doesn't move on the road. Tank always move on the field, right? If field has a water lock, your tanks will not move faster, and so on. So those are interesting. This example of flooding, digitalization models before after flooding, and so on. So satellite has a lot of applications. Another example of fog, and nowadays flight screen delays in Delhi. You must heard news, right? Delhi flight delay, flight delay, flight delays. How why flood will happen? Because of the fog and smog, right? Satellites can tell you data, how much area is a fog and which another alternative route or alternative airport for landing your flights. If this emergency happens, there's a fog is not clear for several hours, you cannot keep your airplane in the air all the time, right? So the fog, another examples. Groundwater, how much water in the deep every day. My district Bandara, where I'm right now in one of the town called Tumsar in district Bandara, right? The water level here also goes down by several meters. Right now, I heard that the water level is around 50 to 60 meters below the surface. Maybe same in Baramat in other areas. We need to know that how can recharge those areas and how much water levels are there and which is monitored by the satellite. So this map shows how water level goes down to the normal water level. Another applications of satellite, remote sensing is also GPS tracking. Now you guys have to track your kids also. You have faculty, I know, right? Where your kids are, you get put applications. But also the small GPS tags can monitor the humans, monitor the animals, monitor the birds, and also monitor trucks and vehicles. There's another applications. Last 5 6 years, drone technology become huge involvement in the remote sensing, not only in civil engineering or water engineering or transportation engineering to map cut and fill. Cut and fill as I know you, a lot of you are civil engineers, right? So we did that assignment cut and fill. Or how much construction happening in nowadays. You don't fly once while and tell them the owner of the company sitting in Delhi or Mumbai and tell you how much work is done today. This is one image. Today's image minus yesterday's image equals to new work. And that's happening. Also, the road construction, how many cracks in the roads can be used by the satellite and drones and LiDAR techniques. Right? These are the some LiDAR systems or application LiDAR systems. Uh, and this is the another application nowadays. A drone can spray the chemicals, right? Right? Or just can spray the NDVI I mentioned before. Right? So there are so many applications of this remote sensing satellite. Not only can take the sensors with you, but also spray the chemicals. LiDAR is another technology which measures the height of the crops or height of the other things. All right. Today, I've been to my village Mundikota, where I visited today, and I went to Gram Panchayat. I'll show the picture after a few minutes later. What you guys did a drone, so that Sarpanch explained me, Gram Panchayat Sarpanch. Sir, आमच्याकडे, sir, we had drones to map entire village, and we mapped the boundary of everybody's property. If you guys from village or town, you might be seeing this one, but drone be used not only my village but several other villages in my area. So this is another application of drone mapping, right? Which also use sensors like visible sensors, but it's still technology. So this is one of the examples of those mapping the land properties of peoples, because previously everybody doesn't have records properly, right? So these are all those applications can be seen to measure all the parameters and we to see this data from long terms. 30 people can tell you that, hey, how much the solvent changes, how much river water changes, how much lake changing, sinking, and so on. So those are applied satellites can help us to see this modern climate change and how can we do better. I'll stop here and happy to answer any questions. Please unmute yourself, raise your hands, and happy to answer any question. Kade sir?
Yes, sir. Yes, sir. Hello, sir. Are you?
Yes.
Sir, our timing is one more hour. That is 6:30 to 8 p.m.
Okay, perfect, sir. So I'm happy to talk to all of your faculty. If they're not sleeping, भाई लोग तुम सो गए, can you give a turn on the camera, please?
Yes,
Let's
yes,
see
yes,
आप
sir.
सो
Yes,
रहे
sir.
हो या
Yes,
जग रहे हो देखना पड़ेगा.
yes, sir. Yes, sir. Yes, sir.
ये
Very,
तो भी
very
फायदा नहीं
important.
सब पता कितना ज्ञान देके.
Yes, sir. Yes, sir.
हाँ. Let me call name. Amol Pardeshi, Amol Sawant, Ashish Gupta. जाग रहे हो सो रहे ऑन पे चले गए.
नहीं, होगी sir.
Let's see how many people. Vijay Singhale, yes.
Yes.
अभिजीत रेवाड़े. सबके नाम लेना पड़ेगा सर, सबको जगाना पड़ेगा. चिन्मय
Yes,
नायक.
from participants.
Yeah, let's see
Chinmay
participant
Naik.
जग रहे सो रहे हैं. Let's see.
Mhm.
अमोल सावंत, आशीष गुप्ता. Let's see सबको जगा लेते सर. मिस डॉक्टर
Yes,
तावरे,
sir. Yes, sir.
प्रियंका तावरे, डॉक्टर बगीशा मथाडा, डॉक्टर गुप्ता. चलो चलो सबको जगा लेते सर.
Yes, sir.
Let's see. प्रीतम घोष, आइए सब लोग चला आइए आगे. लेट्स बात करते हैं कि क्या क्या कर सब में कर सकते हैं और क्या नया कर सकते हैं.
Yes, sir.
Let's see. कविश पटवारी, सिद्धेश नागपुरे. लेट्स टर्न ऑन योर कैमरा. लेट्स सी आप जाग रहे हो सो रहे हो. राइट. चलिए बताइए क्या हम बात कर सकते हैं, क्या कोलैबोरेट कर सकते हैं, क्या नया आपका टॉपिक है. और दो चीज बताना चाहूंगा कि एक रिक्वेस्ट आप सब फैकल्टी से, वक्त में तो आपके गांव के प्राइमरी स्कूल जहाँ आपने पढ़े हो जरूर जाइएगा. आज मैं मेरे प्राइमरी स्कूल में जाके आया मेरे गांव में और बड़ी खुशी हुई अपने गांव जाके और स्कूल के टीचर से मिलके और बच्चों से मिलके. तो रिक्वेस्ट अगर आप हो सके तो इतना जरूर कीजिएगा. राइट. दूसरी चीज और एक बताना था आपको सबका कि आई एम फॉरेन evaluator approved by several universities from Savitribai Phule University and other universities. So anybody doing PhD in engineering, civil engineering, feel free to recommend my name as a foreign evaluator and happy to evaluate your thesis. Okay, so that's another thing I want to let you know. I did several, maybe 30, 40 thesis nowadays, last 2, 3 years, and happy to review few more from if some of you doing PhDs with those universities. Okay, that's another offer. और या और कुछ सवाल कोलैबोरेशन के बारे में? ओके, डॉक्टर को जब बोलिए, लेट मी ओपन द चैट.
हॅलो सर.
हाँ बोला.
सर ॲटमॉस्फेरिक विंडो बद्दल माहिती हवी होती.
एटमॉस्फेयर विंडो.
येस सर.
Atmosphere window, yes. So all the channels I shown you, right? So atmosphere window is at which specific area of the spectrum allow you to pass through, or which spectrum channels allow you not to pass, like cloud, right? So some channels can pass through cloud, some channels cannot pass through. That's the atmosphere window. Like this every window thing, window से light आता ही नहीं आता है, right? Exactly. Some channels are blocked by the cloud. Same concept. अपना window blocked by window वही है.
नहीं नहीं अजून
और कुछ
काहीतरी
कोई
डिस्कशन
सवाल?
Hello, sir. What are the things we need to do for collaboration, sir?
All right, research is the biggest thing to do collaboration, sir. If you guys working in the field of remote sensing, GIS, or you trying to develop any project, because all of you are faculty, right? And एक faculty का progress ये होता है, assistant professor होंगे आप लोग, associate होंगे, तो funding apply करना, right? You apply funding for different agency, right? Here, so if you have any project in mind, right, send me the email, right? Said, Dr. Lakankar, I have worked on this project. I want to apply for grants, and let me know or help me or suggest me what good ideas you having, and I can help you with that, right? And do you write the project? You get the funding. You work on your project. I'm only guiding, or I can provide some suggestions based on the what things we do here. Barabar?
Yeah,
So
that's correct. That's correct.
thing,
Okay.
and once you get funding, the good thing that you can show off your principal, you get promotions and so on. So that's a win-win for you. Barabar? And not
Yeah,
only
yeah.
win-win for you, once you get funding, you can get better opportunity, bigger college and bigger salary. Barabar, sir? So
Yes,
if
sir.
you're new, also that's if you're new faculty, think on that directions. Okay? That's the one thing. Yes, somebody raised the hand. आप किस एरिया में फैकल्टी है? आप थोड़ा बताएंगे, एक एक बंदा, एक एक फैकल्टी जो है स्क्रीन पे अनम्यूट करके, तो आपके बारे में बताइए कि आप किस फील्ड में काम करते हैं. अमोल परदेसी.
I work in the area of reliability, sir.
Reliability. Okay. Dr. Pawan.
Good evening, sir. I work in the area of concrete technology, but I teach engineering surveying to the students, which includes the GIS and remote sensing.
Areva, so
Power-
you're my field.
Yes.
Nice. So definitely, if you apply for any grants or any projects, let me know. Happy to
Definitely,
help you
definitely, sir.
collaborate with you.
I'll
Okay.
write an email to you, sir, regarding it.
Yes. Okay.
Yes.
Happy. Yes. Anybody else? मुझे लगा बच्चे ही डरते हैं, फैकल्टी भी डरते हैं पर सवाल पूछने को, सर. ये
I
बात
also
तो
taught, sir.
हाँ,
Remote sensing and
अरे
technology.
अच्छा अमोल, हाँ बोलिए.
हाँ, मैंने भी रिमोट सेंसिंग टेक्नोलॉजी लास्ट सेमेस्टर में पढ़ाया था सर.
अरे वाह, और कहाँ से पढ़े रिमोट सेंसिंग आप?
पुणे यूनिवर्सिटी.
पुणे यूनिवर्सिटी. पुणे यूनिवर्सिटी किस कॉलेज से?
छत्रपति शिवाजी महाराज कॉलेज ऑफ इंजीनियरिंग, अहिल्यानगर.
अरे वाह, गुड 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 गुड, बढ़िया है. Nice. That is a good area for future also, because India launching a lot of satellites. कुछ बताइएगा अगर फ्यूचर में करना प्रोजेक्ट महाराष्ट्र के लिए, तो हैप्पी टू डू समथिंग फॉर महाराष्ट्र.
श्योर सर।
है ना?
सर करने के लिए तो बहुत सारे प्रोजेक्ट हैं। जैसे
हाँ
कि हम अभी जो सोच रहे हैं कि वाटर रिसोर्स पे तो बहुत काम है,
हाँ हाँ
कि जो बच्चे को उन्होंने फोकस करने चाहिए कि अपकमिंग डेज में जो
हाँ
वाटर का शॉर्टफॉल हो रहा है
हाँ,
और जो अच्छा हमको पानी मिलना चाहिए, वो वाटर का जो क्वालिटी है दिन ब दिन खराब हो जा रहा है।
बराबर।
तो उसके बारे में भी और कुछ प्रोजेक्ट हो सकते हैं इसमें,
यस।
क्योंकि मैंने अभी रिसेंट सेमेस्टर में इंटीग्रेटेड वाटर रिसोर्स में एक सब्जेक्ट अभी पढ़ा है, बी को।
हाँ हाँ
तो उसमें बहुत सारे ऐसे हर्डल्स है कि जो हम उसको अभी जो चैलेंजेस देख रहे हैं, जैसे
हाँ
कि हम अभी बोल रहे हैं कि दिन ब दिन जमीन कम हो रही है
हाँ हाँ,
और कंस्ट्रक्शन डेवलपमेंट ज्यादा हो रहा है, तो उसकी वजह से पानी का जो यूटिलाइजेशन है वो भी बढ़ रहा है। और पानी जो ऐसी एक चीज है कि इट हैज नो अल्टरनेटिव।
हम्म,
पानी को एक ही अल्टरनेटिव है, पानी।
या
तो उसके माध्यम से हमको बच्चों को थोड़ा सा लीड करना चाहिए कि जितने भी सारे वाटर प्रोजेक्ट्स है उसके लिए
हम्म
हमको थोड़ा सा लीड लेकर करना चाहिए। अभी मैं जो पढ़ा रहा हूँ, जितना भी न्यूज़पेपर में या इसमें आता है कि कुछ जैसे कि प्रोजेक्ट रुका हुआ है,
हम्म
तो उसके बारे में उसका केस स्टडी बहुत सारा बहुत जगह पे बताता हूँ। जैसे कि अ, आपके ही इधर एक, जस्ट मिनट, एक प्रोजेक्ट है कि जो बहुत साल से चल रहा है सर,
हम्म
जहाँ पे उसका काम है वो बहुत दिनों से रुका हुआ है।
हम्म,
तो जो भी जितना भी काम है, जैसे कि गोसी खुर्द एक डैम
या
है सर।
यस।
उसमें गवर्नमेंट ने बहुत सारे प्रोजेक्ट पे खर्चा किया है, लेकिन उसका जो आउटपुट जो मिलना चाहिए वो उतना अभी नहीं। प्रोजेक्ट इज रनिंग नाउ 55 to 57%। सो व्हाट
यस सर।
अबाउट रिमेनिंग 43%? तो गवर्नमेंट ने अभी तक उसके ऊपर इतना खर्चा किया है, तो लेकिन प्रोजेक्ट अभी भी 100% इफिशियंसी से नहीं चल रहा है।
डिले हो रहा है, काफी
ऐसे
काफी डिले हुआ कोशिश प्रोजेक्ट। आई एम पार्ट ऑफ द सेम डिस्ट्रिक्ट और सिमिलर नियर बाय, so that project
हाँ,
delay a
आपके ही
lot and
डिस्ट्रिक्ट से बिलोंग करता है।
yeah, so I'm aware of it.
और अभी मैंने बच्चों से अभी बोला है कि वहां पे ऑडिट किया है, कोई एग्जीक्यूटिव इंजीनियर्स लोगों ने ऑडिट किया है। दो
हाँ
तीन ऑडिट रिपोर्ट भी अवेलेबल है कि
हाँ
वाई प्रोजेक्ट डिलेड। डिलेड होने
yeah,
के कारण बहुत सारे हैं,
हम्म
जहाँ लोकल इश्यू है, वहाँ के और कुछ भी हो सकते हैं, बाकी के इश्यू भी है। तो फाइनेंस का तो इश्यू नहीं है वहां पे सर,
yeah,
लेकिन जो भी इश्यू है ये है, मतलब ये इंजीनियर ही सॉल्व कर सकते हैं। सोसाइटी को जितना जल्दी फायदा हो सके उतना सोसाइटी फायदा ले सकती है।
right, right. Sir, ये भी
और
faculties
हाँ तो
these all part of the civil engineering or different area? ये जो सभी जो अभी फैकल्टी ऑनलाइन है, ऑल और सिविल इंजीनियरिंग एरिया से है कि दूसरे एरिया से
यस
भी है?
सर, यस सर। नहीं नहीं सर, ऑलमोस्ट आई थिंक सिविल इंजीनियरिंग से है।
ओके। सो बिकॉज हम लोग का रोल बहुत बड़ा है सर, तो ऑल फैकल्टी ऑफ यू, we have bigger role to play in this whole infrastructure of the Maharashtra. As you mentioned
यस
that satellite remote sensing, surveying, mapping, water resources, because if we not stand up today, we will not have water for drinking in future. And आपने देखा, आप sedimentation पढ़ा, जरूर पढ़ाते हैं sedimentation. All the lakes in Maharashtra are coming to the end of the life because of sedimentations. क्या हम कर सकते हैं? दूसरा biggest problem Maharashtra is the water recharge is less, so water level goes down. So जितना आप प्रोजेक्ट लिखोगे करोगे स्टूडेंट के साथ, it will open the eyes of some people slowly one by one, right? So let's think on that directions. The water recharge, groundwater recharge, and the sedimentation issue. बराबर? एंड सैटेलाइट में भी सर्वे,
यस सर।
सैटेलाइट डेटा है आपका, इन ग्राउंड सर्वे है, ये सब आप यूज कर सकते हैं. How many other faculty are working in the field of GIS remote sensing in this water resources? I know परदेसी है, दो तीन लोग दिखे हैं. सर ये फैकल्टी तो मैं बच्चे तो सो जाते हैं, मैं सुना रही फैकल्टी भी सो जाते हैं सर जूम में. ठीक है सर, अगर कोई सवाल ना हो तो फिर हम लोग यही रुक जाते हैं, या किसी कुछ नहीं पूछना है तो. और सबको एक चांस है, अगर इफ गेट चांस गूगल आप कीजिए, गूगल क्रोम ओपन कीजिए, और मेरा नाम सर्च कीजिए, तारेंद्र एक सर्च कीजिएगा। एवरीबडी प्लीज सर्च, ओपन द क्रोम गूगल एंड तारेंद्र, एंड आपको मेरा इंफॉर्मेशन मिलेगा वहाँ पे। एंड स्टे इन टच, ये बोल सकता हूँ मैं। सेंड मी emails, राइट? Also that if some
सर
kids
आप
are,
पीपीटी शेयर कर सकते हो?
हाँ सर, गुरुवन सर को भेजा है, लेकिन
हाँ
अगर एक काम कीजिए सर, लेट मी शेयर द स्क्रीन क्विकली वन मोर टाइम एंड आई विल शो वेयर पीपीटी इज।
Sir, I have
स्क्रीनशॉट
one
ली है
doubt.
सर।
ओके, एक मिनट।
Sir, I have one doubt.
यस मैम, गिव मी 1 मिनट।
Sir,
तो आप एवरीबडी आप क्या कीजिएगा, आप गूगल पे जाइएगा। मैडम 1 मिनट ना, आपको दे रहा हूँ सर, और लिखिए तारेंद्र लिखिएगा। जब आप सर्च करोगे तो दिस इज माई पहले पे जाएगा, राइट? और इफ यू गेट चांस, क्लिक ऑन दिस फर्स्ट लिंक, and some of the area, my whatever I teach here in CUNY City of New York are here, and then some of the area I mentioned, you can get more information about that. I mentioned about weather station projects I running here, that here, and then if you want interested on the field of snow remote sensing is here. Click on those link. All the work in snow remote sensing. Okay. And if you need more on the soil moisture are here, and so on. So, and then I mentioned, so I also do a lot of traveling. I went to the 42 countries. I'm going to plan 3 more countries this week. This week I'm traveling to Vietnam, Cambodia, Philippines, and those all are here places. Okay, madam, on also I want to highlight that अगर आप किसी बच्चे को मोटिवेट करना है तो मेरी 2-3 बुक है, you can just click on the book and you can open and read it. मराठी बुक इज जेपे का तारा जी, माय नेम इज तारा इज तारा, सितारे की उड़ान, और एक नई बुक ये, सो दैट इज अबाउट मी, सो एंड ऑल ऑफ पीडीएफ अवेलेबल। ठीक है, सो गोइंग बैक अगेन, मैडम बोलिए।
Sir, remote sensing and by using that remote sensing and GIS, can we conduct any study like groundwater, quality of the groundwater, or
नॉट मैडम, क्वालिटी कंट्रोल नहीं कर सकते, लेकिन अब वाटर का डेप्थ क्या है ये जो हम करते हैं, एट व्हाट डेप्थ वाटर इज अवेलेबल थ्रू द ग्रेस मिशन, GRACE ग्रेस। आप सर्च कीजिए ग्रेस ग्राउंड वाटर, 2 वर्ड करेंगे ना, तो उससे आपको मंथली डेटा ऑन द वाटर डेप्थ ये अवेलेबल हो जाएगा। इन वाटर की क्वालिटी नहीं कर सकते हम लोग।
like
हाँ,
whether chemicals are there, whether that water is drinkable or something, whether it is
नहीं मैडम,
contaminated, like that study can be carried out?
नो नो, ओनली थिंग वी कैन लेक वाटर क्वालिटी। अगर लेक है, ओपन वाटर बॉडीज है, लेक, डैम, ओशन, इसका वाटर क्वालिटी हम बता कर सकते हैं, लेकिन नॉट ग्राउंड।
Okay. Okay.
ऐसे
Thank you, sir.
आप इस फील्ड में काम कर रहे हैं मैडम?
नहीं नहीं, मैं तो स्ट्रक्चरल इंजीनियरिंग हूँ, स्ट्रक्चरल
हाँ,
इंजीनियर हूँ, बट आई जस्ट हैव क्यूरियोसिटी एंड वांट टू टेक अप द स्टडीज इन दिस एरिया.
गुड गुड, अच्छा, कुछ लगा तो बताइएगा। देयर आर वन ऑफ माय कलीग फैकल्टी फ्रेंड इन IIT गांधीनगर, ही वर्क a lot in the groundwater and other things.
Okay, thank you, sir.
किसी और कोई सवाल? डॉक्टर सुजाता, आप किस फील्ड में काम करते हैं?
Sir, I'm a structural engineer.
Obviously, sir.
So working in structure.
बोबड़े सर, आपसे आप बात की, आप किस फील्ड में काम करते हैं?
Structural engineering.
Okay. Sorry. ओके और पवन आप किस में होते हैं?
Hello, sir. I teach engineering surveying, and my PhD is in sustainable construction materials from NIT Patna, sir.
Oh, sustainable construction material.
Yes, sir.
The fly ash and other things.
Yeah. I'm using sugarcane bagasse ash, rice husk ash combination with ordinary Portland cement, sir.
Arey wow, nice. I got one thesis last month work on this sustainable product from
Yes.
SPPU.
Yes, sir. Last year, sir, I visited the University of Tokyo as a research scholar, sir,
Very
for
nice.
one of the objective for 10 months.
Very nice, very nice. Good. And Amol, आप फील्ड से बिलोंग करते हैं? यार म्यूट.
हाँ सर.
आप किस फील्ड में काम करते हैं? क्या पढ़ाते हैं?
हाँ सर, मैं IWRPM, दैट इज इंटीग्रेटेड वाटर रिसोर्स प्लानिंग एंड मैनेजमेंट,
हाँ.
एंड इंजीनियरिंग इकोनॉमिक्स.
इंजीनियरिंग इकोनॉमिक्स. सही है.
319 रुपए मिले ले मेरे को, ये 11 मतलब 330 रुपए मिले ले.
व्हेरी नाइस.
मला वाटलं झोपन तो नाही तर नेलं असतं ते.
अरे बाबा. Good. Amol, that's good area, engineering economics. People know the economic impact of all the projects.
Yeah.
So you study on the which kind of projects in engineering economics? You do hydrological projects or water resource projects or structural projects? Any specific area you teach engineering economics?
No, sir, it's just only related to the syllabus of SPPU, just only.
Okay.
Yes. This quality maintenance.
Quality
Related to quality work, yes, sir.
Oh, quality work, quality of the economics. Okay, good,
Yeah.
good. Nice. Chinmay, which field are you working?
Good evening, sir. I'm working as assistant professor in engineering college. I'm teaching structural engineering.
Civil engineering.
Yes, structural engineering.
Oh, structural engineering. Okay.
And we have worked on the bagasse ash, which is obtained after burning the bagasse from sugarcane industry.
Oh, okay. And what are you doing with the ash? You creating some product?
We have used it as a partial replacement to cement. And at some extent, we have used it in autoclave variated concrete also.
Nice.
The result was quite acceptable, but the appearance, due to its blackish nature, color, the appearance was something different than usual autoclave variated concrete blocks.
Understood. That's why people might not like it. But how about strength-wise? Is strength than the
Strength is near about, as we are using regular fly ash and acceptable up to our desired limit.
Oh, nice. Very good. Mr. Dudhal, what area are you working?
Hello, sir. Hello,
आपका आवाज ठीक से नहीं आ रहा है.
दुधात सर और हाँ आवाज ठीक से नहीं आ रहा है. प्लीज जरा रेंज में आइए.
Hello.
हाँ बोलिए.
बोलिए.
Am I audible, sir?
हाँ.
Yes.
Am I audible, sir?
Yes, you are.
Yes. Please continue.
My topic is application of artificial neural network technique by using vectoral-based concrete.
Oh, okay. Structural engineers. Nice.
Yeah.
That's another good area. Just
Yes,
last
sir.
week, I use one thesis from the Mrs. Joshi's student who work on the using a three technology, X boost neural network and other technology for this concrete structure. Nice, nice. Good. That's a good area.
Thank you, sir.
Yeah, it is good area. So definitely in future we need to bring the AI in our every aspect, whether sustainability or a structure, to detect whether it's strength of this concrete materials or cracks in the all those things. We need that. So very good. Good. और कौन है भी? Manisha Wagmare.
Yes, sir. Just now we spoke.
Yeah, this is
Yeah, but my area of research is in earthquake engineering and vibration control.
अरे वाह. So I'm telling you, so if you the area na, if there are smaller sensors you can buy with 100 rupees, 200 rupees. Build a project with the students with the smaller sensors, with the vibrations and other things, and let them build curiosity.
Yes,
अभी
sir.
क्या हो रहा है, हम लोग हमारे आप भी जब हम भी पढ़ रहे थे तब भी we use only theoretical subjects. Lab is less. So nowadays, since because of Amazon, the all electronics items, smaller sensors become very cheap. 100 rupees, 200 rupees. So those smaller money can spend, school can spend, and build a curiosity among students to build some kind of technology with the earthquake monitoring, bolo, yeah, something like that. It could be bring more changes because all the kids, and you're aware of that. Everybody's busy on the phone nowadays, right? How to bring them to the real life other than phone? There's a big responsibility on us, and you guys can do that better. Yeah.
Yes, sir. We have some accelerometers and piezoelectric sensors. Because I'm teaching PG students, so we do some experimentation, small experimentation on that small shake table.
Right, right. That's good.
Yes.
Nice. Thank you.
Thank you, sir.
Yeah. Mrs. Sakshi. आप किस पर में पढ़ाते हैं? आप म्यूट है.
मैडम अनम्यूट कीजिए.
I'm for engineering chemistry, sir.
Engineering chemistry, अरे वाह.
Yeah.
First year.
Yeah, first year engineering.
First engineering. Yes, nice.
Yeah, I heard that discussion. It is also useful, informative for us.
Nice. So आपको तो जरूरी है वाटर क्वालिटी, अगर कोई सस्टेनेबली काम कर रहा होगा, so वर्ल्ड वाटर क्वालिटी से लेके that project definitely you should be part of it.
Yeah. Our entire water quality, the practicals are also there for our course, sir, depending on the water quality, hardness, alkalinity.
Correct. So if somebody working on satellite remote sensing, like another faculty or somebody, you can be part of this. You can do groundwork, and they can do satellite works, and they can do satellite images. Your ground hardness, alkalinity, algae, other growth, and you can write a nice paper as a collaborative among other faculty with remote sensing and water quality testing.
Yes. Already one paper is done, sir. It is in process of publication regarding the water quality.
Is it part of the any lakes or which kind of?
Yes, it is not reminding that journal actually. In 2 journals, I am processing that.
Nice. So is the water quality water from the which part of body, like a lake, river?
River
water quality or river water quality. Okay, good.
Yeah.
Nice. Yeah. So in future you can expand a project, you bring somebody from university area, another faculty, and say you bring images and you bring the samples of the river and match those two things and come with the nice paper.
Yes, definitely, sir.
Nice. Very good.
Okay. Thank you.
Yeah. All right. I think everybody has spoke. Anybody has left? Unless you guys turn on your camera, I don't know whether you guys awake or sleeping, so I cannot take your name. Okay, Dr. Umang, please.
A very good evening, sir.
My
name is Dr. Umang. I am from Jaipur, Rajasthan.
अरे वाह, हाँ हाँ।
Although this is an interesting session which you have delivered to us, and there are many cases over here that with Bhatter Baba, one of the famous name regarding the charging of water bodies, he
Uh-huh.
revived. But I am from the hotel management background,
Uh-huh.
and I really want to work like the carbon footprint, which is in the kitchen, especially in the commercial kitchen, produce during the cooking process. So I just
Uh-huh.
want to, what is the main aim of attending this FDP is that to gain some knowledge regarding the material so that I can inculcate you applicable these material into the infrastructure of commercial kitchen so that we can reduce, that helps to reduce the carbon
Mm-hmm.
which raise during the cooking process.
Right, right, right. Okay.
That is the main aspect, purpose why I have joined this FDP.
Nice, nice. So yeah, that's a good area. I'm not much familiar with your area of I know carbon very well. We know the carbons, but yes. So I think last few years, or maybe 10 years, the amount of carbon from kitchen of Indian kitchen is reduced huge, because previously at villages people used to burn the coal and wood to cook the food. Nowadays, everybody, I heard that getting a gas supply. True?
True,
Yeah.
sir.
Yeah. So that reduce huge load of carbon footprint from Indian kitchen specifically. So that's a welcoming from our side of sustainability, where reduce the carbon, right? Whereas more important. And second thing, health also. If too much of CO2 produced in the coal or wood, right, is unhealthy for any woman who's cooking, right, or man who's cooking. Right? So that's a
Correct,
great.
sir.
So let's see what more can we do. At least let's make sure every household in India should have cooking gas to cook the food, so that this should not be impacted.
Correct, sir. And although we use such kind of material, which helps to reduce that one, it helps to reduce the
Yes.
carbon inside the infrastructure. Thank you so much, sir.
Yeah, very nice. Right.
Good evening, sir.
Parlikar, namaskar.
Namaskar, sir. Sir, in the line
सर
of
तो देखो भाई, पर्लिका सर है, ये मेरे क्लासमेट थे नांदेड़ में इंजीनियरिंग कॉलेज में. सो प्लीज सर मत बोलिएगा.
yes, sir.
तो बुरा मान जाऊंगा. बोलो.
Yeah, yeah. Sir, in the line of the question which just Umang sir has asked, I want to ask: is there any application of remote sensing in the field of virtual water?
Virtual water?
Sir.
No, sir. I don't remember anything. I can't think also at this moment. But let me do some research and come back.
Yes, yes. लाखनकर सर, हेलो.
हाँ बोले सर.
लाखनकर सर, ये जो वर्चुअल कॉन्सेप्ट है वो एक्चुअली सिलेबस में है हमारे. और इसका भी जरूरत कुछ देश अभी इसका एप्लीकेशन कर रहे हैं. मतलब ये जो कंसेप्ट है वो आई थिंक ये 10 साल के आसपास पहले इंट्रोड्यूस हुआ है. जहाँ भी वाटर का स्कार्सिटी है तो वहां पे इसका एप्लीकेशन थोड़ा सा दिख रहा है सर. तो अगर जरूरत पड़े तो यहाँ उसके ऊपर शायद फ्यूचर में बहुत सारे प्रोजेक्ट भी हो सकते हैं. जैसे मैं अभी रिसेंट पे पहले बोला कि बहुत जगह पे ऐसे है कि गुड क्वालिटी जो वाटर है वो उसका स्कार्सिटी बहुत दिख रहा है और डे बाय डे वो कम हो रहा है. तो अभी जो पर्लिका सर ने बात किया कि उसके ऊपर हमने भी बहुत सारी चर्चा की या डिस्कशन किया है. तो उसके ऊपर भी शायद वो लिंक हो सकता है क्या, ऐसा भी सर का कहना है थोड़ा. तो अमल सर भी कुछ बोल रहे. अमोल सर, अमोल अमोल.
Amol, you are mute.
हेलो.
हाँ बोलो.
हाँ सर, मैं भी इंटीग्रेटेड वाटर रिसोर्स पढ़ाता हूँ ना, तो इसमें भी है वर्चुअल वाटर के रिलेटेड. सो आई वुड आल्सो लाइक टू गेट इंफॉर्मेशन रिगार्डिंग रिमोट सेंसिंग का और वर्चुअल वाटर का कुछ मतलब यूज कर सकते हैं क्या?
अभी इस वक्त तो मेरे पास इसका ज्यादा नॉलेज नहीं है, लेकिन थोड़ा मैं रिसर्च करता हूँ, थोड़ा पढ़ता हूँ, एंड आई थिंक विल कम बैक टू दैट. लेकिन इस वक्त मेरे पास इसका कोई सवाल का जवाब नहीं है. लेकिन अच्छा कॉन्सेप्ट, कुछ तो वेरी इंटरेस्टिंग रहेगा. Definitely.
Yes, sir. Yes.
Yeah. Good. Let's talk. This looks innovative, so let's talk. Maybe we'll discuss next time. Yeah. सर ये सारे फैकल्टी आप मालेगांव से ही है या बारामती से ही कि डिफरेंट प्लेस?
No, sir. No, sir. Different place से. Different place से. ये सुजाता मैडम मैं और बोबड़े सर यहाँ से है.
हाँ.
बाकी लोग शायद बाहर के कॉलेज से.
I am from Ahilya Nagar.
Oh, Ahilya Nagar. Nice.
Yes.
Yeah. I'm from Pune. AISSMS.
Okay. Manisha, right? हाँ.
I am from Kolhapur, sir. DY Patil College, Kolhapur.
कोल्हापुर, right? Nice. मैं लास्ट ईयर कोल्हापुर गए थे हम लोग, तो आपके सारे टेम्पल देख के आए. टेम्पल शिवाजी महाराज के फोर्ट्स देख के आए. मैं टीम ले जाके शिवाजी महाराज के सारे फोर्ट्स, सारे नहीं, एटलीस्ट 8-10
जी, कोल्हापुर में एक है सर, पन्हाळा.
Sir, I am from Sangola.
कहाँ से? अकोला?
Sangola.
संगोला कहाँ पे है सर?
Near Solapur, sir. Near Pandharpur, rather.
पंढरपुर.
Near Pandharpur.
तो हम इस कारण से सर हम ऑलरेडी जिला गोंदिया भंडारा.
Yeah, sir. Actually, principal sir was there. No, that Mukne sir was my colleague.
हाँ. He's from this area?
Yes.
No, he was with
Yes. From Pandharpur.
Pandharpur. Okay. Nice.
Sir, and various participants also various states also in West Bengal, Tamil Nadu, Madhya Pradesh, Telangana, Gujarat, Bihar, Punjab, Haryana, Andhra Pradesh. So these are the participants also you have to involve for this FDP.
Oh, okay. So sorry, I thought everybody from Maharashtra. So I speak little Marathi somewhere, but next time I'll speak English or Hindi. So every time I come to India, I travel a lot. So I try to explore different. जब हम students थे तो never get chance, but now I'm getting chance. Each time come, I went Tamil Nadu, I went Rajasthan, little bit MP. So in future, I'll try to go different. And Orissa last year, I took a whole delegation from the CUNY to Orissa and Andhra. So Andhra, Vijayawada University, other university, Andhra University in Vijayawada, we went there. Vignan Universities, Hyderabad. So I'm trying to see that how can we build more collaborations, bring more interactive session with the faculties so that they can learn from us, we can learn from them. It is not one way, it's both the way, and see what can be done. But not only in India, I go a lot of countries. So I went around 42 countries so far, meeting with different people. Now going 3 more countries next week. Vietnam, Cambodia, Philippines. I'm meeting with a lot of people there. So my interest to go at least 100 countries in next 7 years and learn from others also. Same time, exchange the informations. So that's my goal in next 7 years. ठीक है, Kate sir, if बाकी सब लोग are busy or no questions, we can stop here, and I look forward more interaction through email if somebody interested.
Okay, thank you, Lakankar sir, for delivering wonderful and thoughtful session. Your session is valuable and helpful to our participants, also helpful to researchers regarding new area in engineering, agriculture, and AI-based modules. Thank you, sir.
No worries. Welcome. All right, everybody. Good night. See you sometimes.
Good night, sir.
Good night.
Thank you, sir.
Good night, sir.
Good night, sir. Thank you so much.
All the participants, next session will start within 2 to 3 minutes. Thank you.
खरंच sir.
Good evening to all. Today's second session, digital twin-based modeling and design for smart cities. One of the expert for engineer Yogesh Munde. He is the associate principal engineers digital practice DAR AL and consultants India Private Limited. His area of excellence for BIM implementation, BIM consultant, multi-trade coordination. And mainly his skills also MEP, structural modeling from LOD 100 to LOD 400 standards, interior discipline collaboration with BIM management, quality attraction, virtual reality, and also the digital twin. And his skills also, he has many projects in BIM, mainly for this AI Maktoum International Airport, Dubai Arena, Dubai MBR Stadium, then also the La Plage South at the Pearl, Qatar, then Medina Hajj City, Saudi Arabia. And so these are the various projects for the international levels. These are the Ministry of Finance building, Angola, then AI Khalif Mall, Dubai, IBN, Botto Mall, Dubai. It is also the various projects, mainly managers for also these supervise all these projects in the BIM. Yogesh sir?
Yes, may I start? Yeah, thank you. Let me share my screen and just confirm once it's visible.
Yes, please share. Please.
Can you confirm? Am I audible?
Yes.
Okay.
Yes, sir. Yes.
So we will proceed. Before proceeding, if you all put yourself on mute, that will be the great. So we'll not have interruptions. Okay, great. So every year we invest enormous time into the design and constructing infrastructure. And still we have the many failures. And if you see the projects in real life, so cost overruns, and still we have the question why this is happening, though we have the good engineering. So it's not we are not failing because of the poor engineering, but we are failing because of the how we react. So usually how we react when the problem occurs. So let's say imagine if any breach or any building or any city gives us the warning before failing or gives some symptoms before failing, so it will be the easy for us to identify what the issues. Okay. So good evening everyone, myself Yogesh Munde, and past 20 years I'm working in the field of digital practice, where I look after the how technology like AI, data analytics, or the digital workflows that basically transforming the our civil engineering, and more than that, I will say the our AEC industry. So you must be surprised with the title that I have written. So when I started, when Dr. Kate has reached out me and he says that we need to talk about something related to the urban design, smart cities, and started exploring this. And so I said that okay, whatever we are doing as of now, everything is a conventional. So let me talk me something realistic and more about the futuristic. So don't worry, whatever I have gonna present, it's related to the all the topics that has been mentioned, but I change a little bit the topic title probably you will be relate once we reach to the end of this presentation. Okay, so today I'm going to talk about the AI and digital twins beyond smart cities, concepts, application, and the future opportunities. Okay, so uh, before quick my introduction, as I mentioned, past 20 years I've been the part of BIM with Daral Handasa. Daral Handasa, it's a part of Sidara Group. So Sidara Group, it's the world's second largest AEC consultancy group, which basically works into the different domains. So our sister companies like Perkinsville, Tiwylin, Curie and Brown, Penn. So these are the few of the companies. Mufis Engineering. We have the footprint across the globe. The key signature projects that I've been fortunate to work on that. It's like Al Maktoum International Airport, Dubai, which is right now we are working. It's under the design stage, and it's going to be developed till 2050. And then currently I'm working on the India project. If I talk about, it's a Warsaw Bandra Sea Link VBSL, the extension that right now that been design has been completed. We under the review over there. Then if stadium, basically if I talk about the stadium, so you must know the FIFA 2020 that happens at Qatar. So all the stadiums, Alcor and all that one, that has been designed by us, and I'm fortunate to work on that. Then uh, uh, Dubai malls, Bahrain malls, Dubai Arena, basically Coca-Cola Arena. These are the few of the key projects that I've been work. This project basically are developed on the BIM platform. It's a conventional BIM. Okay. So let me quickly take you to the before starting a presentation. Let me give you the quick overview of agenda. What we're going to talk and what will be the outcome at the end of this session. So first, I will start talking about the industry transformation. So understanding why civil engineering is evolving and why we need of intelligent systems. And then I will talk about the AI fundamentals. It is very much important that we need to understand at this stage, specifically when there is a bubble around the industry, AI, machine learning, and a lot of stuff. But realistically, what exactly the AI fundamentals that we will talk, and then we will move on the digital twin technologies. We'll have like from BIM, the conjunctive twins, and the asset monitoring. We'll talk about this digital twin technologies, and then we will talk about the practical applications. So what are the practical applications, and really is it working? Like we are saying that if I say that okay, this is the technology and this okay, that's fine, I'm just saying hypothetically, but really this is this happening? So we'll see the practical applications, and then I will talk about the future directions like skill development, research opportunities, and what are the key research areas that are we have the good opportunity and they are untouched. Okay. Uh, Dr. Kate, can you put mute, please? Everyone, there is an interruption. Thank you.
Yes, sir.
Okay. So let me talk about first transformation, how the civil engineering has been transformation. So I have the simple graphics. So on the left side, if you what you able to see out there. So there are the some checklist, some engineering tools, some reports, some devices, traditional devices. And on the right side, you can see over there futuristic thing, something dashboards, some tabs, some signaling drones, satellites. Okay. So what is our traditionally civil engineering is relied on. So it is more on the reactive methods where the maintenance was carried out only after the failure. Once the failure occurs, then we'll start with the maintenance. And the decisions, more the decisions were mostly based on the individual's experience and the data analysis capabilities. So if I have to make a decision, so obviously we go with the seniors, we talk about his experience, but there is no tool whether the senior, whatever he's saying, there is no validation or there is no certain benchmarking on which basis this data has been come, or on what basis we are making this decision. Okay. So inspections like were periodically done, meaning we check the structures and at the fixed intervals rather than the continuously. Okay. So while this approach worked earlier, and it often led to the unexpected failures, higher in the cost, and basically the safety risk. So this is the overall outcome of this. But if you have seen day by day, the infrastructure that we are building. So simply, if I considering earlier we were building a simple homes, but if you right now see if any person has to build a bungalow, he comes with a lot of interior requirements, elevation requirements. Even with if you have seen the commercial buildings, it involves a lot of facade, complex design, some digital shapes, and some a lot of complexity, design complexity involves. So due to this complexity in modern civil engineering, what it demands exactly? So it demands proactive and intelligent approach. If so, it's a simple, like for example, if I'm earlier I've been using only keypad phones, but now we are getting smart. I have the smartphone. Have you changed your mindset for using the smartphone? Obviously, I'm not following the my conventional mindset that earlier I've been using with the keypad phones. So this is exactly same happening. The way we are becoming a smart, my design, my buildings, my everything is becoming smart. So what what we need, so as I mentioned, manual decision making, limited data analytics, these are the traditional approach. And what are the my modern requirements? So modern requirements, it's more talk about the predictive analytics, so preventing my costly failures, data driven insights, optimal decision. If I have to make a decision making, I will not make it with a random experience or someone's certain benchmarking. I will go with my data. So it's a data era. So that's why specifically I have mentioned here the data driven insights for optimal decision. Then intelligence system to processing real time information. So I need an intelligent system where I'll get a real time information. Okay. Then continuous and the continuous monitoring and rapid response, that is also essential. So in general, in summary, if I say that it's a do civil engineering just building a structure? No, it's about managing a set intelligently throughout the my project life cycle, starting from concept up to the maintenance and operations, using the my advanced technologies. So this transformation basically sets a foundation. Obviously, if there is a technology has come, there is a needs of a certain foundation. So what kind of a certain, these are the basic foundations that are the essential for the concept like AI, BIM, and the digital twin, which we will explore now further into the presentation. Okay. So before getting into the much deep dive into the technicality of the understanding the AI and digital twin, let understand first a key drivers for the AI and digital twin adoption. Okay, so what exactly the artificial intelligence drives? So first, aging infrastructure. So aging infrastructure, it's basically the day by day, a large portion of our bridges, road, utilities are reaching out and their limit, and they have already exceeded their design lives. So a traditional inspection based maintenance is no more sufficient. So if if you have seen, if you consider within the Pune, you have the so many bridges, and it cannot be the we cannot inspect it manually. Okay, so in order to overcome that, what we need a smart continuous monitoring that can assess my structural health in real time, and it helps the external services and to the service of the my entire life of this asset. So first key driver for the my adoption is the aging infrastructure, right? The second sorry, second important driver, rising cost. So rising cost, the construction and maintenance expenses are continuously increasing due to the my materials prices, labor shortages, and more project delays. So how to overcome this one? So for this, rising cost optimization is must for the my project. So here AI will help and address this by enabling a better prediction, better optimization, and efficient my resource allocation to the my project. So it will reducing the both my operational as well as the life cycle cost. Okay, so the third one, third driving factor, it's safety management. So safety management, the safety in India, forget about the safety. We never think about that one. But uh, in general, if you have seen in terms of engineering, safety is another critical factor. So infrastructure failures can have a serious human and the economic consequences. So with if I have the AI driven predictive analytics, so it will can identify, so we can identify risk at a early stage, monitor the critical parameters continuously, and prevent the accidents of uh, instead of reacting to them. So as I mentioned at my start of that, why we fails, because we react after failure. We are that's the our major key. So safety management, if I have the predictive, if I react before happening, I will get a more enhanced risk assessment on that part. Okay, and the finally important one, sustainability goals. So the we are in the decade where the sustainability is one of a key factor, and our entire industry now moving around the sustainability. So if you have seen, in every project it says that it has to be a sustainability. So modern infrastructure, it's my moral responsibility that my model infrastructure or my design must minimize the environmental impact while maximizing the my performance. Okay, so with the minimal my environmental impact, I need to improve my performance. So this digital twin allows life cycle based optimization. Okay, helping engineers to reduce the waste, energy consumption, and the carbon footprint. Okay, and we will say that our most trendy term, green building. So it will support our green infrastructure initiatives. So, in summary, if I say that key drivers that are for the adoption, but in the convergence of sensors, cloud computing, big data analytics has made AI and digital twins. It's not just feasible, but the essential for the modern civil engineering practices, right? So let's after that one, let's move on the next part. It's about understanding the. Let me move on this. Understanding the artificial intelligence. So you heard about like AI. So many things are come up. So what exactly AI is? Okay, just give me the 2 minutes. There is a voice interrupt. I need to ask them. Okay, just give me 2 minutes, please. Sorry for the interruption. Okay. So we were talking about the understanding the artificial intelligence. So what exactly AI is? So AI is nothing but it's an ability of machines to perform a task that normally require the human intelligence. It's a simple. So any task that require the human intelligence, instead of that been it's been performed by the machines. So it includes learning from data, pattern recognition, and making the predictions. These are the key factors. So when I say the first capability, learning from data. So what does it mean? Learning from data means what exactly? So what AI systems do, it improves their performance by analyzing the historical and real time data. Okay, so for example, there is a data from the past projects, sensor readings, or the inspection records that are available. So it helps AI to learn how structure behaves over the period of a time. So it analyzes this all this data, and it can see that okay, in this experience how this structure behaves, what was the observations that has been come up, and it will make some predictions. So this is nothing but a learning from a data. Then second is the pattern recognition. So pattern recognition, so the I'll always say that we are roaming around the data. What we are right now consuming, we are consuming a data. So everything it moves around a data, which involves it has certain patterns. We cannot be analyzed. A human brain cannot analyze this huge number of data, or it cannot identify the pattern exactly. So AI, what AI helps us, AI can identify this hidden relationship within this data. It understands the trends and anomalies that has been for this large cluster of data sets. Okay, and when this pattern is identifying, it will easy for engineers to understand or to analyze this data in better way. Okay, and the third capability, it's as I mentioned, it's a prediction and the optimization. So AI can forecast, or they can do the future conditions, such as load behavior, deteriorations, or the maintenance need. It can be predicted with this prediction and optimization. Okay, and it can be, and then it can be suggested that optimize what will be the optimal solution for this one, or uh, it will help us to make to make a decision or to understand the problems in better way and make it faster decisions. Okay, so a very important point that I have mentioned over here. So this is a very critical point, and I always say that AI will not replace the engineers. We need to understand. Instead of that, it will enhance decision making first. How? The decision making by processing vast amount of data that provide the actionable insights over my design. Okay, so but it will give me the analysis and all that one, but the final judgment, responsibility, and the engineering wisdom, it will be the always with the engineer. AI cannot take this wisdom, or AI will cannot take the accountability of my structural, okay, structural safety. So AI should be, in my opinion, viewed as a powerful decision support tool, not a replacement to the engineering expertise. Right? So let me move on the next slide. It's about, let me go on the next slide. It's about the AI, machine learning, and deep learning. And now we are getting, I am into the little deeper. So is the AI only the one thing? No. So this will help us now. The next what I'm going to discuss, it will understand. It will help you to understand the relationship between the AI, machine learning, and the deep learning. Okay. So let's understand what's the artificial intelligence. So when I say that AI is the overall concept of creating, as I mentioned, intelligence system that can help, like that can perform like a conjugative task such as reasoning, decision making, or problem solving. So in civil engineering, basically, the system can assist into the planning, monitoring, and the decision support. So within the AI, so if I say the within the AI, we have machine learning. Okay, so machine learning, what machine learning do, it focus on as I mentioned, it focus on the algorithms that learn the patterns from data. Okay, rather than being explicitly programmed, it will understand the pattern from the my data that has been provided. And as more data becomes available day by day, these models gets improved. So initially there will be the lesser data, but periodically as my over the time, I will get a more data. So it will do the more effective pattern analysis. So for example, if I have to say that, like, what exactly the machine learning? So machine learning inspect the data that to predict the deterioration and the maintenance need. Okay, so we talk about the AI, then machine learning, and let me talk about the next stage, that is deep learning. You must heard about this deep learning. So it's a more advanced subset of machine learning. So deep learning is a multi-layers, basically. A multi-layers, we says that in technical language, neural network. It called as a multi-layer neural network. So just like a human brain. So if you have seen our human brain, we have the multi-layers. It's nerves. So similar way, this is nothing but a deep learning. So it is particularly powerful for the handling unstructured data such as images, signals, videos. Okay, so in civil engineering, if I have to say that, okay, what exactly the deep learning? So it's like crack detection from the images, or the drone based infections, or the traffic analysis, or structural health monitoring. So this is nothing but my deep learning. So if you have seen this carefully, this image, I'm not sure whether you are able to see the minute details of this graphics, because this graphics a little bit distorted, but this diagram on the left side, this represents the hierarchy for the deep learning inside the machine learning, and machine learning inside the artificial intelligence. Whereas on the right side, if you have seen this image, it shows the how these models are connected directly to the real infrastructure system. Okay, so in summary of this, the key points of this one, it's a AI defines the goal. What AI do? AI defines a goal. Then machine learning provides the learning capability, and deep learning enables the advanced perception and the analysis. And together they form a technology backbone for the my modern applications such as the digital twin and the intelligence systems. Okay, so let's understand in the application of the civil engineering, because right now I'm talking more into the IT infrastructure, and some of could be the board with all these technical terms. So let's understand in the civil engineering. So when I say the AI, so you can see over there, it's automated crack detection in a concrete structure. So you can see here AI system can automatically, so it is basically a bridge, and where you can see that there are the cracks, it's been captured by the my images, and where we can classify. So AI can classify and can inspect this one, and we can see the criticality of the my crack, and it will help me, or it will help the engineers to prioritize the my maintenance more effectively. Okay, so this is nothing but a artificial intelligence in the civil engineering. Then machine learning. So machine learning, it's basically, so it's a predicting a traffic pattern. So you can see over there, it's basically a urban design. So when I do the urban planning, so to understand the traffic pattern prediction. So how we gonna find out the traffic pattern prediction? Obviously, by analyzing the historical traffic data, sensor inputs, and the real-time condition. So let's say if I have to do the planning for my road, so in order to have the more effective my infra, what I need to apply my logic. It's about understanding the traffic pattern, understanding the traffic data, sensor data, and as of now, what is happening at this place. So that is nothing but a real-time data. So with this data, machine learning can predict the congestions, optimizing the signal timings, and the support better road network planning. Okay, ultimately this helps the cities to improve the mobility, and while reducing the delays and obviously fuel consumption. So fuel consumption, there was the study this happen if we just waiting at a signal for the 30 seconds, or more than 60 seconds, what is, how much is the fuel consumption if I turn off the my vehicle, and then again starting again do the ignition. So this entire year study that has been happened in the Nagpur, and they found that there is a more fuel consumption happen just due to the signal time. And with this data, they arranged more effectively a sync of a traffic signaling. Okay, so this is nothing but a machine learning. Then next one is the deep learning. So deep learning is used for the structural load forecasting. My bad, I missed the image. It's again, I have applied for the machine learning. It should be for the deep learning. Sorry for that. So it's basically a structural load forecasting in bridges and the buildings. So deep learning models, it's basically a process large volume of sensors to understand the complex structural behavior under varying load conditions, varying weather, uses conditions. So it will understand all these things, and this is especially useful for the assessing my structural performance and supporting the early warning systems. Okay, so these three examples basically give you the insight that how effectively we can use this latest technology into a civil engineering. So, in summary, these technologies help civil engineers more from the inspection-based decisions, predictive and the proactive asset management, forming the strong foundation for the my digital twin and the smart infrastructure or sustainable infrastructure systems. Okay, then next we'll talk about a little bit machine learning. So basically, when I say the machine learning, we have the three type of machine learning. So first is the supervised machine learning. So in the supervised machine learning, what we do have, we have the label data. So in this case, in supervised learning, the input and output both are known to me. Okay, what the algorithm learns the relationship between them, and it makes the predictive predictions on the new data. Okay, so this is nothing but a supervised learning. So in terms of civil engineering, what is a supervised learning? So it's a basically predicting a structural loads based on the historical sensor measurements and the understanding the load patterns. So this is nothing but a supervised learning. Then next is the unsupervised learning. So unsupervised learning, here there are the data are unlabeled. The algorithm job is to discover. The algorithm will discover the hidden pattern and it will group on its own. So in unsupervised, you don't have to give any criteria for the grouping or anything. It will analysis himself and it will do the grouping. And there is a, in this case, just similar to the supervised learning, there is a predictive outcome. But here, there is a no predefined outcome in unsupervised learning. So in terms of civil engineering, if I have to talk about the unsupervised learning, so what will be the, so it is nothing but a clustering a traffic pattern to identify congestion zones or abnormal traffic behavior, which can then be later we can use for the optimizing my signal timing and the urban planning. So that is a unsupervised learning. And then third one is the reinforcement learning. This basically a trial and error reinforcement learning. So just similar to the supervised learning and unsupervised learning. Here there is nothing predefined or nothing the output or input. It basically a trial and error. So what system takes? So system takes actions. It receives a feedback in the form of rewards or the penalties, or gradually learns from the best strategies. So continuously, uh, in terms of civil engineering, if I have to give the example, optimizing traffic signals. The earlier one was the clustering the traffic pattern. Reinforcement learning is nothing but optimizing traffic signal systems where the algorithm continuously it's adjusting with my real time data to reduce the congestions and the traffic flow. Okay. So if I have to give you the quick one liner, or so it will be the easy for you to understand the pattern. So supervised learning, it is nothing but the predictive known outcomes. Unsupervised learning discovers the hidden patterns, and reinforcement learning, it learns the optimal actions. Okay, so together will all these three methods or all these types, it enables intelligent, adaptive, and the data driven decision making in the modern civil engineering. Okay, so we'll move next one now. I told you about AI and machine learning. I talk many technical terms and lot of stuff around over there. But why AI matters for the civil engineers? Why it is important? So first important, most critical one, it's a data processing power. AI's data processing power. Why it is essential? Because as I mentioned, modern infrastructure generating a massive volumes of data, uh, sorry, from the sensors, from the IoT devices. IoT term, you must be aware, Internet of Things. You may search on the IoT devices, inspections, my monitoring systems, and manually analyzing this data is practically impossible. And it's data in the gigabytes. It's not easy for us to process all this data to understand this process. So AI can process and analyze these complex data sets quickly and more efficiently. So it will helping engineers to focus on the decision making rather than data handling. So you don't have to handle the data. It will be the taken care by the AI. What you have to do, you have to analyze this outcome of this data. So it will help you once you have the all the analyzed data without handling and all that, you have the directly efficient decision making. Then pattern discovery. So if I ask you, if I give the certain predictive data or certain historical data, and if I ask you understand the relation or find out the what the pattern is happening when this with this received logs or the information. Technically, is it possible for a human brain? No, it takes ages to define the pattern. So pattern discovery, where the machine learning algorithm can detect the subtle correlation and the trends and the anomalies that for the large scale infrastructure data patterns, and the human observes might be the easily miss. So this cannot be the pattern discovery, cannot be the easily find the humans. So this is critical for the early detection of the issues such as the structural deteriorations or the abnormal my system behaviors. And the third one is the, as I mentioned, the important one is the predictive capabilities. So AI enables me to predictive maintenance and the proactive risk assessment. Instead of reacting to the failures, engineer can anticipate the problems. They can optimize the maintenance schedules and allocate the resources more effectively across the entire life cycle. Okay, and then the essential principle that we have to which is very important, what AI do? AI augmenting the engineering expertise. It's augmenting. It's not replacing the engineering expertise. Here is the important key that you have to. It's not replacing the my expertise, but it is augmenting. So professional judgment, domain knowledge, and the technical, ethical responsibility. It's remains fundamental for the civil engineering practice. What I say is uh, professional judgment, domain knowledge, and the ethical responsibility. This is untouchable. AI cannot replace in the basic civil engineering. So what AI do? AI will support engineers by providing insights, but the final decisions and accountability will be the always live with the engineer. Clear? So, AI is helping civil engineers to move from the reactive approach to predictive and optimized decision making. So, this is making my infrastructure more safer, more infrastructure, and more sustainable. Okay. Now, I will quickly start. This is up till now we have talked about the AI and all the technology and all this. Now we'll talk more about digital twin infrastructure, the uses into this civil engineering. So before that one, let me give you the conventionally right now that is happening in the industry. It is nothing but a BIM. Most of you must heard about the BIM. It's I will not go in much detail about this. So it's nothing but a BIM. It's nothing but my static digital representation of physical and the functional characteristic of the my facility. It is not just 3D model. It is more about the information repository that supports my decision making throughout my project life cycle. Is starting from the concept design up to the my maintenance and the operation. Okay. So if I say the what is the general BIM process, so it's a very layman's language right now I am giving, but it's not that much straightforward BIM process. It's like model creation, collaboration, clash detection, documentation, and the life cycle management. This is basically a general BIM process. And due to this, what happens? I get a enhanced visualization because whatever gonna build actually, that is I'm building at digitally. So BIM is a nothing but my digital prototype. Okay, so whatever I'm gonna do actual construction, that is I'm doing a digitally. So it's a design, build, and operate. This is nothing but my project life cycle, and it has stages. It has a lot of islands, and all has been connected by a single file database management, which is nothing but a BIM. So this is the which is my foundation. So when AI is integrated with BIM, model becomes a more intelligent and they can learn from the design patterns, automate repetitive tasks, provide the predictive insights, and transforming my static BIM into the dynamic decision making platform, which is a digital twin. Okay. So let me talk about exactly uh, up till now nth time I talk about the digital twin, and I'm continuously mentioning digital twin, but what exactly the digital twin is? So a digital twin is a nothing but a dynamic replica of my physical asset. When I say the physical asset, what are the physical assets? It's nothing but my bridge, my building or road, anything. That is a physical assets for me. And it is a that's dynamic digital replica of this physical asset is nothing but a digital twin. Very simple. Okay, so unlike of in the BIM, I have the static model. So I do not have the continuously update, real-time update on that model. But where my digital twin model will receive the continuously real-time data from where the sensors and the monitoring system that has been installed by us with the actual assets. Okay, so this allows my digital model to reflect what is happening in the my real world. At any moment, I can find out what is happening. Okay, then it has a the first. Now I will talk about the characteristic of a digital twin. So first key characteristic of a digital twin, it's a live connection. So digital twin always stays synchronized with the physical assets, capturing the my current conditions and perform my matrices in the real time. If the asset behavior changes, digital twin changes immediately. It reflects. The changes are reflect immediately on the my digital twin. Okay, so this is the first live connection. Then second one is the my data connected. So a digital twin integrates data from the multiple sources such as sensor, IoT devices, inspection records, or the operational system. So it collects the data from everywhere into a where it is connected. All this data has been connected. It is connected to the single database, which is nothing but my single unified model. Okay, and then third important one, it's like that is a continuously updated. So it evolves. My digital twin, my physical assets evolves over the time, reflecting the changes in the structural behavior, uses pattern, or the environmental conditions. It's everything is so rather than remaining it fixed, it keeps at a changing at any design stages. Okay, so that is a continuously updated. So digital twin transforms my design models into the living breathing system. So in nothing but, so like for example, my BIM is nothing but a dead body, a human's dead body. Digital twin is nothing but my live body. So where you have the everything is immediately. So if right now if I put my hand over this chair, and if there is something wrong with my chair, and if I get hurt by this chair hand, immediately I'll get updated. So similar, if my building is getting hurted with a certain performance issue, here the performance issue with my chair, so I come to know with my body. So similar way, the how the body react, similar way my building will react. Where? Digital twin. So that is dead body and live body. Keep simple into the mind. That is nothing but a digital twin. Okay, so digital twin allows engineers to monitor, to analyze and improve the infrastructure before problems becomes a failure. So if there is a problem, you will get a immediately notification. Will not wait till it fails. Okay, so next, let me, oops, what exactly the BIM and the digital twin, the difference of over there. So you can see over here on the left side, this is my digital world, and on the right side, digital twin, it's a digital world plus the physical world. So as I mentioned, BIM is a primarily a static model which is created during the my design or construction execution or the my construction phases. So it is a more design focused, supporting the my planning, coordination, clash detection, whatever I'm doing. So BIM contain the rich information about the geometry, materials, specifications, but they do not have the live data. So when I say the BIM, it talk about the my more design focused, more about the primarily it talks about the my material, my specification, my characteristics, everything has been, but it do not have the, as I mentioned, it do not have the live data. But when I say the digital twin or even the historical data, it do not have. On the other side, on the right side, I have the digital twin. So when I say the digital twin has a, let me minimize, it has a dynamic model. So it has a continuously updates, or it's a continuously evolving on the basis of real time data and the monitoring that has been received from the monitoring. Unlike to the BIM, it is more on the life cycle focus, so supporting the operation, maintenance, and the asset management. Okay, why it is? Because it integrates my real time data, and the digital twin provides the predictive insights such as forecasting the failures, optimizing the performance, and important one, supporting proactive decision making. So in this diagram you can see over there, starting from the BIM, from digital world, how I am evolving from the digital plus physical world. Okay, so in very simple words, what BIM tells us, BIM tells us what we have designed and built, while digital twin tells us how asset, or how my physical asset, or how my building or infrastructure is actually performing today, and how it will performing it in the future. Okay, clear? So this is nothing but a difference between the digital twin versus the BIM. Okay, so there are the, let's understand the few core component of a digital twin. So digital twin, it's a sophisticated visual representation, as I mentioned, the physical infrastructure and which bridges the gap between the real and the digital world. So in order to understand digital team in the civil engineering, we need to understand the fundamental components of the my digital twin. So what are the there are the 5 blocks of our digital twin components. It's a physical assets, which is you must now get the, in this term very easily. Bridges, buildings, roads, these are the nothing but my physical assets. The second, sensors and the IoT devices. Sensors and IoT devices, these are embedded and installed into my physical assets, and this data is continuously captured with real world data, like such as strain, temperature, vibrations, environmental conditions. And this data forms are have the live connection between the physical assets and the digital component. So if I have the BIM, and I need to understand the BIM's stress and strain, all these conditions, the or the behavior of my BIM or the temperature. It is captured via this. Yes. Okay, I'll continue.
Please continue. Please continue.
Yeah, sorry. And then the third block, that is a data platform. Data platform, it is nothing but a cloud-based system that collect, store, and process this massive volume of a sensor and real-time data. So this platform ensures that the data is reliable, scalable, and accessible for the analysis. Okay, and then fourth one is the analytical and AI layer. So here the my machine learning and AI algorithm analyze the raw data that has been compiled over this data platform. It will identify the pattern, detect anomalies, on the generate predictive insights. So this is where the data is converted on this platform into the meaningful engineering intelligence. Okay, and the next block is nothing but a visualization and decision interface. So dashboards or the visual tools that presents sorry, complex information on easy to understand format, enabling the engineers to make it a fast and informed data driven decision making. So physical asset, sensors, IoT devices, data platform, analytical and AI layers, and the visualization. These are the 5 key component or the 5 blocks of my digital twin. So it's like a jigsaw puzzle. You bring the all this in order to solve that one. You bring the all the blocks you bring together, and then you solve the jigsaw puzzle. So digital twin, nothing but a jigsaw puzzle. All the what are the these 5 blocks? Bring all this data. Each block says something, says some. It has a certain functions, and then finally you are solving this puzzle. Okay, next. Now, little more dose on the digital twin. So we have the basically 3 categories of a digital twin. So first one is the we says in our language, it's a design twin. So design twin is nothing but it is used before construction begins. So my static at a design stage. So it enables a detailed simulation and validation of my design decisions, helping engineers to identify the potential issues early. So let's say if I built a tunnel or a road, so we do the transit analysis. So transit analysis gives me the insight whether the my design that has been designed it is reliable or not. It is really work in a real world. So that simulation is nothing but my design twin. So using the design twin, we can perform the structural performance modeling. So design twin, right now I'm talking about the structural perspective. So earlier I talk about when I say the transit analysis, I was talking about the infrastructure perspective. So right now I'm talking about the structural perspective. So structural performing model, uh, test difference between the load scenarios, optimize the materials, evaluate the multiple design alternatives. So this is significantly reduce my the errors and the costly changes during the construction. So this is nothing but a design twin. Then the construction twin. Construction twin, it is nothing but it provides me the real-time visibility into the my construction process. So it helps me to track the my schedule, whether the my construction progress is happening as per the my schedules or not. Whether I have the all the monitor quality control, it has a safety compliance, whether I have the optimized resource allocation. This is everything is happen at a construction twin. And then operational twin is nothing but my maintenance and operation. So maintenance and operation, this is a in long term digital twin. So an operational twin continuously it's going to keep continuously tracking the my asset. So my building, it will keep continuously check my building health, how is my building, whether it's breathing properly or not. So this is nothing but my operational twin. Okay, so in summary, if I say that design twins support the better design decisions, construction twins ensure controlled and efficient execution, and operation twins enable the my uh, sorry, something is happened. So operational twin, it enables the intelligent data driven asset management. Okay, so these are the basically 3 category of a digital twins. So evaluation of my AEC model. So it's a like from 2D drawings, then the BIM models, then the digital twin, and then cognitive twins. So cognitive twins is nothing but my infrastructure AI enabled or AI power my intelligent digital twin system. Okay, So key transformation for this one is nothing but my digital twin plus intelligence, the artificial intelligence, that is quantitative infrastructure that learns, adopts, and the predicts. So this evaluation basically represents a shift from the drawing-based engineering to intelligent driven, or I will say the data driven infrastructure management. Okay, so predictive, what, let me, because I have the so many windows of this Zoom, so title is not clear to me. Now it's clear. So it's basically a from static to predictive intelligence. So when we start with the BIM, it is a static documentation, right? Then digital twin, it is like what is happening now. And then conjugative twin, it is nothing but my what will happen next. So in simple words, when I say the static to predictive, so BIM is my past, digital twin is my present, right now, what is happening. And when I say that cognitive twin, it is nothing but a future. So where I have the predictions. Okay. So this is digital twin is nothing but from static to predictive intelligence. Okay. Then this is a quick, I think we are running little out of time now. It's a 9:05. So I will run little fast on this. So how AI powers the digital twin intelligence. Okay, so this process, you can see over there I have mentioned 1 2 3 4. So this process is basically start with the sensor data collection. So sensor data collection, as I mentioned, like I have the IoT and all the sensors, that data has been captured, strain gauges, accelerators, environmental sensors that has been installed into the my physical assets. This provides me the live and reliable picture how the structure is behaving. And then next is the again processing, as I mentioned, machine learning algorithms that are involved. And third one is the actionable insights. So actionable insights is nothing but based on the my analysis, AI generate predictions. AI gives you the generate predictions. Okay, and it gives the recommendations to the engineers, and then the engineer's responsibility to see the analyze to identify the signs of deteriorations or the estimating the what are the remaining service life. This is nothing but my actionable insights, and then informed action on the basis of all these 3 points. So using these insights, schedule the maintenance such as optimize interventions to be planned, operational adjustment. This can be implemented at a right time. So this is nothing but a informed action. It's not action. So if you see the carefully sensor data collection, when I say then AI model processing, and here last 2 point, I'm mentioning actionable insights. So actionable insights, it means AI at this analysis giving me the certain actionable insights which I need to validate as engineer, as a engineering expertise, and then informed action, that is very much important. Okay, so in summary, AI is the brain behind the digital twin, which turning my real-time data into a foresight and the intelligent action. Okay, so what are the AI techniques in the civil engineering? So when we say the civil engineering, there are the many AI techniques. But this is a quick summary of the AI techniques that are transforming specifically a civil engineering, because AI is a vast, but out of that one, which techniques are very useful for the specifically civil engineering. So first is the regression model, where we predict a continuous values such as structural load capacity, settlement, material strength based on the my historical data, and they are especially useful for the performance prediction, and the capacity assessment. Then neural network. So neural network, it is advanced models that can capture. This neural network is nothing but advanced. It is a next stage of a regression models which captures non-linear relationship in the structural behavior and the failure mechanism, and they are widely used when the traditional equation struggles. So traditionally I'm suffering, I'm not able to find anything. So neural network will step in and they will represent the real world behavior accurately. And then the third one is the time series analysis. So infrastructure monitoring generates the sequential data over the time, and these time series models that help identify trends and the seasonal effects in the structural health monitoring system, and they support the warning system basically. So that is nothing but a time series analysis. Then computer vision, it is something new term probably you heard, or this is a another powerful technique basically using the images. Computer vision is nothing but using the images from the drones, cameras, and AI can automatically identify or automatically see this all the raster images and analyze what is happening, how much are the cracks, corrosion, my surface damage, or the dimensional changes that can be identified with this computer vision. Okay. So this will reduce my manual inspection. And finally, the optimized algorithm. So finally, I will get these algorithms helps me to get a optimized solution basically. So this technique basically give me the best solution which based on the all the my uh, parameters that has been earlier we have seen, and it will give me the cost effective and more efficient project delivery. So this in summary, all these AI techniques, these are help me from the analytical engine behind the digital twin. It enables the civil engineers to move from rule-based decision to data-driven, productive, and optimized infrastructure management. So traditionally, we go by the book, rule-based, certain experience and all that. So we are moving as a civil engineer. I'm moving from the this rule-based decisions to data-driven, predictive, and the optimized infrastructure management. Okay. So this is when I say the computer vision. So computer vision, it's basically I will give you the quick overview. When I say the computer vision, so what is in exactly it means? So it is nothing but a automated visual intelligence. So at the first application of a computer vision, it's a crack identification. So the images captured from the drones, cameras, computer vision system automatically identify and measure the surface crack within the millimeter up to the millimeter level precision. So this replaces my time consuming manual inspection and ensures that the consistent and repeatable results across the large structures. So it will help me to identify which are the my critical crack. Then the early corrosion identification. So AI model can easily detect early sign of rusting, material degradation on the steel structures and the reinforcement. So by identifying this corrosion at early stage, engineers can plan the maintenance before significant damage to the my structure. Then the safety monitoring computer vision, it's like a real-time verification, like PPE compliance, or we say the detection of unsafe behavior and the monitoring of a restricted zones. So this will help me safety monitoring basically. Okay. And then quality inspection. So AI based visual inspection can verify the dimension and the assesses such as the finishes, and it checks the converses against the design specification with high accuracy. So this automatically improves my quality control and reduces my rework during the construction. So computer vision basically, uh, uh, what it's do, it's transforming my visual data into actionable intelligence, which making inspections faster, safer, and more reliable in the modern civil engineering. Okay. Then next one is the now up till now I have given you the all the way information about the digital twin and all the AI and everything. Okay, infrastructure and everything. But now, civil engineering practical applications we will see. So in structural engineering, it's a predictive asset management. So basically, AI powered applications that has been used for the breach health monitoring, fatigue life prediction, damage localization, and the maintenance planning. If I go on the construction engineering, yes, any question? Okay. So in the construction, basically, it's for the schedule delay predictions, cost overrun analysis, safety risk detection, and the resource optimization. That are the essential. Transportation and the smart cities. So if I talk about the infrastructure, so digital twin technology helps my the smart cities. How? Basically, for the virtual replicas of my road networks to simulate the traffic flow in a real time and enabling the dynamic route optimization and congestion prediction. Pavement monitoring, AI-powered sensors that detects the cracks, deterioration of, and the structural issues before they come critical problems. Then the smart signal systems, so signal synchronization. So due to this one, and it's real time and periodically keep updating, helps me to reducing the my wait time and the emissions, and it make an impact on the my sustainability. So green design, and then urban mobility. So the urban planning, it's very much essential also. Urban mobility is becoming basically when the more than 50% of a population is going to be residing into the urban areas. So as a part of a civil engineer, or as a it's our civil engineer's social responsibility that we need to uh, uh, design, or we need to give the urban mobility system that optimize my public transit, bike sharing, and the pedestrian pathways for the seamless urban movement. Okay. So these are the applications. I talk about only the structural construction and the infrastructure, but there is a geotechnical, there is a steel structures, there are the finite elements, high rise structures. So many things are there, but due to the time limitations, I have given this optimized application of this one. So a quick case study, let's say if I have to build the breach digital twin. Now up till now we have seen everything, what are the essentials, what are the digital twin. But let's say if there is a breach and I have to do the digital twin for the breach. So what the core component that we need? It's a strain sensor track for the structural stress, vibration sensors, temperature sensors, and AI prediction model forecast for the maintenance needs. So these are the core components for the my bridge. And how basically my bridge digital twin works. It's basically a data collection. Then again, the first integration. AI analysis and my proactive actions. And then this overview overall approach give me the entire digital twin. So there is a like study that has been happen. So when you adopt a digital twin approach or the BIM approach, so over the safety, the long-term maintenance cost that has been reduced by the 30%, which is I feel that it's a promising amount. Okay. This is the quick evolution of a BIM to digital twins. So right now I am giving you the insights. Now we are no more working as a conventional BIM. We are moving from the BIM to digital twins. So you can see whether we started with the BIM earlier, where we were only building a digital smart 3D models. But now then we move to the my BIM simulations, BIM plus simulation, and then we move to the scan to BIM, where I'm taking the existing where I was talking about the existing structures and doing the scanning, and then what happen after scan to BIM? What comes? BIM plus AI, then BIM plus IoT, and then what comes? Then comes BIM based AR VR. It is a virtual reality that has been come, and now we are moving towards the digital twin. Okay. Now I talk about a lot of digital twin. Digital twin. Is there any project happen on the digital twin? Yes. This is the London-based skyscraper. It was digital twin was adopted for the sustainability to simulate the building's energy performance and identify the opportunity to the improvements. Okay. So in the buildings, this skyscraper has been used in the London, and the another one is the Crossrail London project, which is a infrastructure project where the digital twin was used for the construction progress and to identify the potential issues before it comes the major problems in the execution. So this is a infra project. Okay. uh, After digital twin, what you says that you said all these are something what's been done by the others. So what we are doing as a DAR. So internally within the in the Pune, like when we have the projects, we have developed a Gemini AI assistant, which helps us in the Revit to generate the instant script generation, one click execution and automatic. So overall our project cost that has been project hours that has been saved per project due to the automation is 60 to 70%, and 95% accuracy is improved. This is done by us. This is what I did. Okay. And one more that I will show you it quickly. This is a Revit API assistance. So what this Revit API assistance do? No more you need the code knowledge or anything. This is a assistant. You have to just API assistant which reads my Revit API and which help me to generate a code or to write a script, write a code for me. So this AI API assistance right now, it's generating a code on the basis of my requirement. Okay. This is what we did. In addition to that one, I'm happy to say that DAR has a in the world, DAR is the only one company who has developed own digital twin platform, which been awarded is the only one platform which is the most trusted as of now in the industry for the digital twin. and that is called as the para. And I was fortunate to part of this para development part where I handled the BIM part, and still we are developing under my team. We are developing the digital BIM enabled digital twin models, where we incorporate this into the our para platform. So if you go and Google the DAR para digital twin platform, you will find a lot of stuff around. We did our own few of the projects on the para. It's Dar's own building, which is in the Egypt. Our Egypt head office has been done on the para, where we did the predictive analysis for the elevators. We found that, like during the maintenance, we found that. I will take your 2 minutes. I know that we are running out of time, but I feel this is important to share a real time example. I will tell you, we were having the six elevators, six lift. So we during the time, over the time on the para, we have observed that the first two lift has the repetitive major maintenance, whereas the last two lift have the minimum maintenance. And when we studied the pattern, so pattern gives that by human nature, whenever someone comes, they always use the first two elevators or first two lift very frequently, and the last two are the lesser one. So we started the lift uses odd even days. So due to that one, our maintenance cost has been reduced. So this is the real time example that we found. Similar way, we found our uses. This is by the way, this is Dar's head office in the Cairo. It is a fully green building, and we received the green building certification. So we studied for the sensor based use of my lights, sensor base of like if I have the occupancy for the 40 people, so my light will be the for the 40 people occupancy. So sensor will automatically identify with this cubicle or with this cubicle how many people are right now available. So let's say the 20 peoples are as of now available on the desk, and according to that my light will be adjusted. So this helps us to control the our light consumption. Okay, so this is up till now I talk about everything digital twin and all this. Now I'll close. In future, what are the essential skills that are required? So the first most important, strong civil engineering fundamentals. No matter how advanced the technology, but the deep understanding of structural mechanics, materials, and geotechnical principles, that remains the foundation. So fundamental of a civil engineering, that is a must required. In this reference, I will share one my experience that when we were exploring certain automations for the Revit and all that using the Python and the Python RPA. So the logic that we followed in the M3 during the derivatives and all that, that makes me to think in rhythmic way to find the logic for the automation. So when I was doing the BE, so at that time we always say in my why we have the M3? What's the use of this one? How we gonna apply it on site? But that M3, that is for the algorithmic thinking, that I realized when I started exploring or started working on the automations. So that are the essentials. So strong civil fundamental, it is irreplaceable. It's not about the application. There are the like yesterday there was the AutoCAD. Today there is a Revit. Tomorrow there is a AI. But all my civil fundamental, it is as it is. Then, second key skill, that is about the BIM and digital modeling. So proficiency, you need to understand what exactly the BIM and what are the tools that are essential, how it basically works. Then important one is the data literacy. Data literacy, it means, as I mentioned, we are consuming the data. So unless and until I do not understand what data is and what I have to do with this data, so you need a more data enabled engineer who can understand the data terminology, who can analyze the data, who can interpret the what exactly the data means, and they can have the more insights from this data. Okay. Then basic programming like Python and the automation skills that are must. And who are right now at if there is a someone with undergraduate or the postgraduate, take my recommendation, learn Python. You must need a Python. Okay. Why? I will show you in next 2 minutes. And then AI concept understanding. AI concept understanding, you need to understand the AI, what exactly the concept, and you need to think more like a civil engineer, how I'm gonna utilize AI into the civil engineering. Okay, what are the machine learning principles, as I have shown you, what are the limitations, what are the applications into the engineering context. Okay, so these are the essential skills. What are the tools for the design and modeling? Revit, Civil 3D, InfraWorks, these are the few tools. There are the nth tool, but I'm just giving you the most efficient tool that as of now the most of the companies are following. For the data analysis, Excel, SQL, Python. For the visualization and IoT, sorry, Power BI, IoT sensors, cloud platforms like AWS, Azure for the data storage. These are all the DevOps. These are the few tools that are the essentials. Now, I have seen like more, if there are the someone who wants to do the research into the future optimistic. I'm not claiming these things, but in my opinion, if I say that if I have to go for the some certain research or anything, so these are the few areas which are still untouchable, and there is a no research is happening at that pace as of now. So first, structural health monitoring. I'm talking about more into the sensor base IoT. You will say that okay, there are the structural best practices. So that's why you are saying that. No, I'm talking about the structural health monitoring, developing the advanced sensor networks, predictive algorithms to assess the infrastructure condition in real time. So this is a one of research opportunity. Then smart materials. Smart materials, it's nothing but self-healing concrete, adaptive materials, embedded sensor technologies into the my materials. So then AI model explainability. So machine learning decision can how it can be more transparent and trustworthy for the critical infrastructure application. Then the digital twin frameworks and the sustainable infrastructure. So these are the few and these topics I will specifically mention ideal for the MTech, MS, or the who if anyone is going for the PhD research programs. In my opinion, as per whatever the small experience that I do have on that basis, this is what I feel, which is essential for next 5 and 10 years, and which is going to be a game changer. Okay. These are the obviously it's not easy to do the research on that. So there are the challenges and limitations in terms of data and availability. Initial investment are the high, model accuracy, validation, cyber security concerns, ethical responsibility. So these are the few of the challenges and the limitations. Okay. So if I have to say the what are the key takeaway of all these whatever I have shown you. So first, enhanced intelligence. So AI basically, again, I will says that AI will not replace the engineers. It basically amplifies our capabilities. It enables the better prediction, smarter optimization, and more informed decision making. Then second layer is life cycle thinking. Second key takeaway out of this one. So digital twins fundamentally change how we approach the infrastructure. Instead of focusing only on the design and construction, we gain the continuous insight from the concept up to the construction, operation, maintenance, and the further decommissioning. Third, hybrid expertise. The future civil engineer is a hybrid professional. Mark my word. So, future civil engineer in the next 5 and 10 years, he's going to be a hybrid professional, someone who combines the strong domain knowledge, civil fundamental knowledge, with the digital skills, then data literacy and understanding the AI driven systems. So, this hybrid expertise is very essential. And then data driven future. So, data driven future, it's as civil engineering evolved towards the evidence based decision making, not more, no more experience, and it's more evidence based. So, powered real time data and predictive analytics. This shift improves the safety, efficiency, and sustainability in long term asset performance. Okay. So the final, if I have to say in one line, what I will say that like AI and digital twins are not just a technologies. They represent a new way of thinking about the infrastructure and the engineering practice. Okay, so for the civil engineers or for the structural engineers, like it's embracing the shifts will define success in the next generation of civil engineering. I'll say we say the Gen Z. So this is nothing but a Gen Z of civil engineering. So my final thought uh, overall, it's a AI and digital twin. It's basically represents the shift from the failure to preventing them, from static design to living system, from front assumption to evidence, from front just assumptions to evidence based decision. But at the center of this transformation, civil engineer. He will be the remains a civil engineer. The center of all this transformation center will be the civil engineer. So technology supports our work, but the accountability, ethics, and the judgment will be the remains with the engineer. So the future of our industry is belongs to the engineer who can blend intelligence with the integrity and the design infrastructure that truly serves the society. Okay. So I will close my presentation on this node, and this is my final thought on this one. And we already 7 minutes overdue. Sorry for that because I have a very bad throat infection, and since last night I was not able to speak. So I went very slow in my flow. That's why this time is exceeded little bit as expected. And if you allow me, or if you, Dr. Kate, if you allow me, I wanted to show you what is happening in industry, what future is coming. If you allow
Yeah,
me,
yeah,
just
yes, sir.
there are the just
Yeah.
two small videos that I wanted to show you. I will show you, and then I will talk you. So look over there. This is a agent basically. Okay, for the structural engineering. Okay,
Mhm.
so this agent is nothing but Dr. Gunwant Kate, a structural engineer.
Acha.
So I am creating a Dr. Kate, and I'm
Mm.
building, and I'm saying that what exactly the data that I have given the data, and I'm giving the application what wants to do the script SAP 24, whether I want the desktop control, What is the desktop control? That I will say restrict the software UI. And it's now starting the my agent. So I have giving him the software user interface. I am training my module. I am saying that what command is useful for this. This is a node. So create a custom joint. Okay, special condition. So each command, this node has been explained. So you can see over there, it's taking. So this is creating all the agent. Okay, it's preparing, it's understanding the my software UI, all the UI elements. Okay, it learns. Now UI element has been learned. Then next is the my other analysis stuff. So rapidly it will create the multiple all the my commands that are essential to for the running the application. This has been done. Okay, export. Now I am exporting the my agent. So I am exporting agent means I am exporting Dr. Kate, who is my expert structural engineer. And then what will happen next stage? I have went over there this chatbot. I took my agent. What I need? Scripting. So whether you need a scripting, and I am saying that I have a 3-story building, SAP 2000, analyze it, optimize, design material cost, and show me the results, walk me through the step and work. So my 3-story building, within 30 seconds, it will give you the results. So can you imagine?
Really? Yes, yes.
So,
Sir, very good experience through this learning.
yeah. So SAP 2000, it's generate, and not only this
Yes,
one, it is
yes.
associated with
Yes.
my design application. Okay, so
Yes.
I will share 2 more links with
Wonderful
you
session, sir.
later
Yes,
on. You
yes,
can
yes,
see over
yes.
there. One is about the
No, no, sir.
this is a within the 30 second they have designed 30 storage tall building. You must
Yes,
watch this
yes.
one, and another one is the
Mhm.
GenFA. So
No, no. Actually, sir, Yogesh, sir, actually, we expected these videos before in between your session
mhm.
because of there is a wonderful session regarding AI-based models and applications in different civil engineering. So I think in future, what we our basic needs: food, water, shelter, and fourth need is I think needed AI. AI is application
Obviously,
in everything in
yeah.
engineering, agricultural, and so many.
Mm.
So thank you for enlightening and engaging session and beneficial to everyone. I think this session wonderful, and I think it is very valuable and helpful to new researchers, MTech students, PG students, researchers, as well as some research scholars, and very helpful that needs. Yogesh sir, we will meet personally in our college for a student session
Sure.
by personally, that is attending not virtually,
Mm.
because wonderful sessions for that this particular. So I once again thank you, Yogesh sir, and thank you all participants. Any questions from participants, please ask.
Sir, could you please give those links?
Yeah, sure. I will share
Video
with
links. Yeah.
Dr. Kate, and you can go through that one. You can reach out to the as I would happy to if I help you anything, if I change your thought process, or if I give a new perspective to you, I'm more than happy that if you found this session useful and it helps you in by any means in your day-to-day life working. Any
Yes, sir.
questions or
Yes.
anything? I know that it's
Yes. Any from
lengthful.
audience?
Hello,
Please.
sir. Myself, Professor Suraj Jagtap. Sir, I'm very thankful to Yogesh, sir, Yogesh Munde, sir, for briefing us artificial intelligence, machine learning, deep learning, reinforcement learning. The way you are discussing everything is very, really nice, sir. And digital twins is nothing but the future era of everything. So thank you
Absolutely.
for guiding us. Very nice. Yeah. And one thought you told us. every UG or PG student must have to go for Python learning. Yes,
Yes.
very nice,
Yes.
very nice thoughts. Yeah, yeah.
Yes,
Thank you.
yes.
Nice to meet you, sir.
That is must. That's why I said that
Yeah, yeah, yeah.
in
It's
future,
the
Suraj, it is going to be like download Yogesh Munde 1.0, download Yogesh
yeah, yeah.
Munde 2.0, download Dr. Gunwan
Correct.
Kate 1.0. It is going to be like this only.
Learning
Updated
Python
versions.
or simply
Yeah.
coding languages, programming
Yes.
languages
Yes,
in
yes,
need of the
yes.
times. Yeah, 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 yeah.
For the
Thank you.
undergraduate, those who are the seniors, for them, you need to understand the Python concept so that it is very much essential. You don't need to be master of that one, but
Yeah.
whoever the seniors, obviously, their career has been set at a certain level. So those who are like been in industry past 20, 25 years or that, and I'm not sure whether you are following the portals or not. There is a no more billing engineer or the quantity surveyors job.
Yes.
Few there. We are not hiring the
Definitely.
quantity
Yeah.
surveyors. What we are
Yes,
hiring,
yes.
VDC manager, virtual design consultant, who knows the 4D, 5D,
Virtual design concept.
whatever I have
Yes,
shown,
yes.
it's a just tip of iceberg. If I have to talk, I need more than 3 to 4 hours, and I will give you the more boring stuff. You
No,
must.
no, no, sir. It is very more informative session
Yeah.
because many audiences experienced your models, your applications, and your knowledge, because which is helpful to our participants. Yes,
Just
sir.
to
Yes. Anybody or?
The twins are like nothing but checklists in the project, I feel.
No, it's more than the checklist. It's more than a
Yes,
checklist.
yes.
Okay. So as I say that digital twin, it's nothing but a live body. And let's say if you are monitoring the BP, you are doing the 2D echo. So when
Yes.
you do the 2D echo, you come to know your heart had a problem. So similar way, building sensors has that. Building heart has a problem. So if we considered my body is nothing but my building. So what you do for the you do the insurance, you do the healthy diet, all this nothing. When you see that, okay, I have the vitamin D is lagging. I have the lesser vitamin D.
Sir,
So what do
one
you
more
do?
Yes,
thing.
yes.
You
Sir,
took
one
out
more
that.
thing.
Mhm.
Sir, how can we implement these techniques in
Mhm.
geotechnical engineering? I'm basically a geotechnical engineer.
Geotechnical, I have a lot of interesting stuff for you. Due to the project confidentiality and all that, I'm controlling myself.
No,
But,
sir,
the
basic
so
doubt is, I'm telling you,
mm,
the soil is
analysis, I will
different at
come to.
different points,
Yes.
and getting data is very difficult.
That's why I'm saying that everything is a data. So right now we have the geotechnical engineering where right now we are working on the AI based certain research we are doing, certain automations we already did for the geotechnical, where at early stage of a projector for in order to do the design analysis and before proceeding with concept and planning specifically for the structural engineering, we did a lot of things, especially when we were doing this VBSL project. So we did the soil analysis and all that. Probably we
Yes,
will
yes.
meet it
Okay.
once in person, then not on this platform. Then we may talk.
Yes, yes, yes. Yes, yes. Okay. Anybody or? Okay. So thank you, sir.
Thank you, thank you. I
Thank
would
you,
like to
Yogesh sir.
thank
Thank you,
you, Dr.
participants.
Kate, to reach me out and give me this wonderful
No, no,
opportunity
no. It's
to.
it's
And
it's our pleasure, sir. It's our pleasure because this session is very helpful to us. Not only industry, but researcher and academicians are very important. One point of view.
And again, for
Okay.
the sorry
Thank
for the
you. Thank
extended time
No, no,
because
no,
I'm
no.
a little unwell, so that I was going
Yes,
very
yes,
slow.
yes,
Okay.
yes.
Okay.
Okay.
Thank you.
Okay.
Shall we
Okay.
close?
Thank you. Yes, sir. Yes.
Okay. Yeah.
Thank you. Good night to all.
Good night.
Yes.
Thank you, sir.
करेंगे मी बंद करतो हा थांबा की टाकतो
Right?